Hey everyone, and we are back again with part 2 of differentials in calculus. In part 1, we handled tough questions and built confidence. So now we are moving to cubic functions. So here guys, we are talking about those curves with twist and the terms that can have two turning points. So today I'll show you how to differentiate them, find their turning points, and also figure out which one is a maximum or a minimum. So as you know guys, that cubic function look complicated, but once you master their derivative, which is part 1, they're actually easy. So now let me show you how. Starting with question 1 from Limpopo, they say that we're given a function f of x which is equals to x raised to an exponent of 3 there. So if you have to check the order of this function is 3, meaning you have a cubic function followed by a quadratic function and then a straight line and then a constant. And always remember that this d here, it is a constant, and it is always the y-intercept of your original function f of x. So this is where your function it is going to cut the y-axis. So now they say that with the following properties, they say that at x is equals to -2 and at x is equals to 1, your function it is equals to 0, meaning y it is equals to 0. So where do we have y to be 0? We have y to be 0 whenever we want to determine the x-intercept of our function. In this case, it is f of x. So it means now this is what? This is your x-intercept. Now, these are your x-intercept then. So you can coordinate them and say this is a, this is -2 when y is 0, and you can say this is b, and you have 1, and then y is what? Is 0 there. So now they see that, remember, when you take the first derivative, that's the gradient. So they're saying that at x is equals to 1 and at x is equals to -1, the gradient it is 0. So meaning that your 1 and -1, those are your critical points. Remember, the critical points are the x-intercept at the turning point. So at the turning point, the gradient it is equals to 0. So this is the turning point here. So this is 1, and then you'll have -1 and then 0 there. So they say now at x is equals to -1. Now y it is 4. So you're just going to say when x is -1, y it is 4 there. So now they say when x is equals to 0, y it is what? It is 2. So where do we have x to be 0? This happens when we want to find the y-intercept. We let x be 0 to our original function. So whenever you replace everywhere there is x with 0, you see that you're just going to have a constant that I have already explained that this is a constant. So it means now d it is what? It is 2 then. So it means now you can say this is a point 0 and 2. And this is where your function it is going to cut the y-axis. So now they say, remember, the first derivative it is the gradient. They say the gradient it is less than 0, meaning the gradient it is negative, or the gradient is your function f of x is what? Is decreasing, or the gradient is what? Is negative. Remember, when you have the slope of a negative gradient is what? Is like this, or the slope, or a negative slope is something like this. Nah? It's something that's decreasing like that, sloping downwards. Nah? Not going inclined like that. So now they say now the gradient it is negative between these 2 points, -1 and 1. But remember, this -1 and 1, they are your critical points at the turning point. So it means now the gradient is what? Is negative between these 2 points. But we also we know that the value of a is what? Is greater than 0, meaning that we will have a function that starts by increasing and then decrease and then what? Increase. So this is our turning point there, and we also have this turning point here. So between these 2 points, you can name this is -1 and 1. Our function is what? Is decreasing. You can see it is sloping downwards. It is decreasing. So they're telling you now the gradient between these 2 points is what? is negative, and this is true. The gradient is negative like this, and then your gradient will start to be what? Positive. And then here it is what? Positive. The gradient here is 0, and then 0, and then positive like that. So it means now between these 2 points, your gradient is what? Is negative there. So now let's try to answer those questions there. They say that we have to draw the graph of f, indicating clearly the coordinate of the turning points and the intercept there. So remember, we need the x-axis. This is the x, and we also need the y-axis. So this is the y there. So we're just going to make the substitution or indicate the coordinates there. So we have -1, or the intercept, we have the intercept, this is -1 and -2, and also have a +1, and the intercept here it is you can see this is 2, and the intercept here it is 4, and x is what? Is -1. And remember that they say that the gradient is negative between these 2 points, meaning the gradient is what? Is sloping downwards like that. So, and this makes sense, guys. You can see that whenever you have a line that goes like that, it means it has a what? A negative slope. So it means now this becomes your maximum, and then your function is going to cut at x is equals to -2, and then you'll have y-intercept at x is equals to 2, and then you have a minimum at x is equals to 1 there. So this will be your function. So this is f, and you can coordinate and say now you can name this to be a, and say this is 1 and what? And 0, and you can call this your b if you like. So this is -1 and 4, and you can say this is your c, and you can say this is -2 and 0. So remember, guys, that the what is this? The roots of this function here. This is where your function what? Intersect what? The x-axis, and this happens at -2 and what? And a +1. And remember that since the order is 3, we must have what? How many roots? 3 roots. But if you have to check here, we have 1, 2. Remember, roots, guys, is where the intersection of your function and the line y is equals to 0 happens. Remember, this is the line y is equals to 0. The x-axis is the line y is equals to 0 there. No? So everything is 0 there for y. So it means now you have how many roots? You have 2 roots there. So where's the other root? Here you have 2 repeating roots, guys. Or you have repeating roots here. You count twice. Whenever you have a minimum or whenever you have a maximum like that, you count twice where your function cave up or cave down. You have repeating roots there. So it means at x is equals to 1, you have repeating roots. So now we are done with that, with the sketch there. So now let's take a look at the next question. They say that in 1.2, we have to determine the equation of f in the form y is equals to. So guys, whenever the roots are given or whenever the roots are known, you use this formula f of x, it is equals to what? A into x minus x1, and then x minus x2, and then x minus x3. This is the formula that you will use. So since you have repeating roots there, it means you just say x minus x2, and then what? Simply square it there. Since you have repeating roots, you know that when you solve for x, you'll have the same x intercept or x value there. So now we're just going to make the substitution, and remember they said we have to call this f to be what? We have to call f to be y. So this is y is equals to a into x minus our x1 is -2. So you protect like that since you have a negative, and then you have x minus 1. You don't need to protect them. So you have something like this. So now, guys, we just need to solve this. So this is the same as a into x plus 2. And then this 2 here tells you now you have the squared binomial. You know how to deal with the squared binomial. You simply square this, the first, or you simply square your x and then square also what? Your 1. And then multiply these 2 and then times by what? By 2 there. So you square this one, this is x squared, and then multiply these two will give you what? X times -1, it is what? Is negative x. So times that by 2 will give you what? Negative 2x. And then square this one will give you what? A positive 1. Since 2, it is an even number there. So now, what do you need to do after this? Remember now we have what? Y is equals to. So now what you have to do is to first distribute the x inside. It means you're going to have what? You're going to have y is equals to a into x cubed, and then x times that you have minus 2x squared plus x, and then now distribute the 2, you'll have plus 2x squared minus 4x plus 2. So now if you have to check there, you have like terms. Now this and this can rationalize. You have x minus 4x. This means this is going to give you what? It's going to give you y is equals to a into x cubed, and then x minus 4x is going to give you minus 3x plus 2. So now this is your function. But what is the value of a? We know a has to be greater than 0, meaning we have to have positive value there. So but how do you deal with that? First, let me erase this thing there, since we have everything that we needed, or the information that we needed. So now, guys, how do you find the value of a? You're going to find the value of a by using another point, or also realizing that 2 is a point to your function. So p, you can name it p and say this is p, and then 0 and what? And 2. So remember, this is x and y. So it means y is what? Is 2 into a, and then 0 cubed minus 3 into 0 plus 2. And then this means this and this rationalize. You'll have 2 into what? 2 times a will give you 2a divided both sides by 2. So therefore, a is simply 1. So you have to take this a is equals to 1 back into that. So since a is just 1, it's not going to affect when you multiply it inside. So you just have the inside function. So therefore, y, it is simply what? The inside, which is ax, okay, x cubed minus 3x squared plus 2. And remember, I told you about this 2, that this is where your original function is going to cut the y-axis there. So this is actually what you will have there. So now, let's take a look at the next question. So this is 1.3, guys. This is that if g of x is equals to f, but now they're evaluating your original function, which is f, at what? At x minus 3, meaning they are shifting f 3 units to the right. Since this is negative, remember, when you say negative, you just take the opposite of this. When you solve for x here, you say x minus 3 is equals to 0, and then therefore x is equals to what? 3, meaning now you are shifting your original function 3 units to the right. So since you're shifting your original function, these 2 will still remain to be 2. And then here you'll have a certain x value, but it will not still be 1. And this the maximum will not be happening at -1 there. Maybe here, or maybe this one there. You see, so you're just taking this function and then moving it 3 units what? To the right there. You're moving each x-intercept or each value there 3 units to what? To the right. But the y remains the same. Ne? You're not changing y because you're not shifting your function vertical. You're just moving it horizontal. So you're not changing y, but you're just changing x, guys. Since you can see this is x minus 3. So it means now your g of x is going to be what? You're just going to say now, remember, they need what? The x-intercept. So remember, the original roots of this f of x is what? Is x. You can say x1 was what? Or is -2. And then x2 and x3. Remember, you have repeating roots is just what? The 1. So now we are shifting this function 3 units to the right. So this is 3 units, means you just adding 3. So you add the 3 to your x, add the 3 to your x. It means now here you have what? You have x1 to be what? to be negative 2 plus 3 will give you just 1, and then here you have what, 4. So it means now this point will be somewhere there, understand, and then this point will be somewhere at what, at 1. So that's how you deal with that. So you can say now, therefore this will be what, the x-intercept of g. So the x-intercept of g, you can limit x equals to 1 will be what, 1, and then x and 2 and 3 will be just 4. This is why it is 2 marks, because they know you have repeating rows there. So they don't want to give you 3 marks saying let's mark him, or let's mark here, or give it 2 marks here, and then here 1 mark. So they know that you have to know your basics, that you have repeating rows there. So enough guys with the talking. Now let's take a look at the following question. See, I hope that you understood that. So you simply add, guys, you simply add 3 to what, to each value of x there, or 3 to each root of what, of your function f of x. So now they say in 1.4, they say that we have to determine the values of p for which x squared minus 2x plus 2, which is equal to p, will have exactly 1 root. So guys, if you have to check the function that you are given here, the order is 2, telling you have what, a quadratic function or a parabola. So whenever you are dealing with the root of a parabola or a quadratic function, you have to look at 3 scenarios. Number 1, you have something like this. You have something like this. That's your function there. And then the second scenario, you have something like this. Then the third scenario, you have something like this. So if you have to check, guys, remember the roots. I told you that the roots, this is where the intersection happens. This is where the intersection happens. A horizontal line, intersection of a horizontal line happens. Not a vertical line, but a horizontal line. It is going to give you what, the roots. Meaning here you have what, 2 roots. What about here? You'll have repeating roots. I told you about that whenever you have a function that curves like that, up or down, you have repeating roots. Whenever you have a minimum, guys, at x or at y is equal to, remember this is a line, y is equal to 0. So whenever you have a line there that just cut at the minimum or at the turning point, you have repeating roots. So here, what about here? You don't have roots here. So we say this, we say here that there are no real roots. You just have imaginary roots here. There are no real roots. So here you have what? You have you can say there are real roots. You can see them here. What about this one? Also the same thing. There are real roots. But if you can ask yourself, what are those roots? Are they equal? The answer is no. So you see, unequal. You have real roots, but also they are unequal. What about this one? You have real roots, but what are they? They are what? They are equal. So there are real roots and what? And equal. So now, whenever you are dealing with the roots of a quadratic function or a parabola, guys, remember that whenever you want to find the roots of a quadratic function, you always use this formula, the quadratic equation, which is x is equals to what, minus b plus and minus the square root of what, of b squared minus 4a, and then c, and then everything divided by what, by 2a. So remember that once the inside here, what is inside the square root, once it becomes negative, this is going to be undefined. So this is what determines your roots, guys. So since here you have no real roots, it means now the inside, we call the inside there, the discriminant. We call the discriminant, which is what, the b squared minus 4ac. So this is the delta, meaning the discriminant. Now, so this is the discriminant there. So you use these guys whenever you want to find what the roots of your quadratic function, whether you have exactly one root or something more than that. So since here you don't have real roots, it means now this inside there, it is what is negative. Once this becomes negative, it means this is undefined. You cannot find what the root of your quadratic function. So we're just going to say that, okay, the b squared minus 4ac is less than 0, meaning negative. So here the b squared minus 4ac, it is equals to 0, since you have what real roots, and what are they? Those roots, they're equal. And then here, since you have real roots and they are unequal, it means now b squared minus 4ac is simply greater than 0. So now the question is, determine the values of p for which x squared minus 3x plus 2 is equals to p will have exactly one root. I hope by now you got the answer. Here is where we have what? Exactly one root. You can see we have one root. Not root, but one root. You have one root. And those roots are what? They're just repeating. So it means the way you're going to tackle this question, this is x squared minus 3x plus 2p. So x squared minus 3x plus 2 is equals to p. That's what I saw there. Yeah, I think that's what I saw there. So now you're just going to say now, remember, they are looking for what? Exactly one root. So it means you're just going to say b squared minus 4ac is simply what? Equals to 0 there. And I'm answering 1.4. So it means you're just going to say, okay, b squared minus 4ac, it is simply what? Equals to 0. But what is b and what is a and what is c? So now to find BAC, first you have to take this to what? To your left, so that you can solve for x. So that you can let this left hand side or the right hand side be 0. So it means now they're going to do what before this? You're going to say now, this is simply x squared minus 3x plus 2 minus p is equals to what? 0 there. So now this becomes your a, your b. Remember, the a is just the coefficient in front of what? Of x, in front of x. So this part now becomes your c. So it means now you're just going to say, okay, the b is what? The b is negative 3. You just take the coefficient, and then the a is simply 1, the c is what? Is 2 minus p. This is has to be equals to 0. You'll have 9 minus 4. 4 times that will give you, okay, let me just keep it like this first, and then this is 9 minus 8 plus 4p is equals to 0. And then this will give you 1 plus 4p is equals to 0. So therefore 4p is equals to negative 1. So then divide both sides by this rationalize. So it means now therefore p is simply what? Negative 1 all over 4. So now let's go back there. So it means now therefore our p here, it is simply what? Minus 1 all over 4. So how do we confirm if this is the correct answer? How do we confirm? So now let me just erase this. So how do we confirm, guys? It's so easy to confirm. You just go back to your function, this function then. You're going to say, let me use let me see which one to use. Just use this one. I hope you can see this one. So you're just going to say x squared minus 3x plus 2 is equals to what? Negative 1 over 4. Remember, p now is what? Negative 1 over 4. So we are trying to prove or confirm if we'll only have one root or repeating roots. So now when you take this to your left, you'll have what? You'll have 2 plus 1 all over 4 like that. It means now you're just going to have what is this? You're going to have 8 plus 1, that's 9 all over 4. So it means now you have x squared minus 3x plus 9 all over 4 is simply equals to 0 there. So it means now you're going to do what? You're going to use that formula, this one here. So it means x is equals to minus your b, it is what? It is minus 3, and then squared, not squared, remember it's not squared, plus minus the square root of what? Your b, it is what? Is negative 3, and then squared the minus 4. Your a is 1, and then your c is 9 all over 4. And then everything you divide by 2 into 1. So now let me take out my calculator now. So this is going to be what? This is going to be negative into negative 3 plus the square root of negative 3 squared minus 4a into 9 all over 4, and then 2. So the answer is simply what? 3 over 2. Let's check the negative one. Do I delete the device? Just okay, like that. You see, it's still the same, guys. Even if you use positive, no? You see, use positive. The answer is 3 over 2, no? We use negative. The answer is 3 over 2. So you see, you only have one root, which is just what? 3 over 2. So therefore, P is exactly 1 over 4. But you didn't need to go ahead and prove that. I just wanted to show you for the sake of learning and understanding what's really happening there. So now, guys, let's take a look at question 2. They say that in the diagram, the graph of f, it is equals to negative x squared. So now the value of a is what? Is less than 0. We'll have a function that starts by decreasing and then increase and what? Decrease there, like that. And this is exactly what you have. Remember, this value of, or the constant, always the constant is telling us about what? The y-intercept. The y-intercept is where your function cuts the y-axis or intersect the x-axis. So they say ABC at the x-intercept of f, t is the turning point, f at g is a point on x-axis, and on x-axis such that tg is perpendicular to the x-axis. So meaning you have a 90-degree there. So now let's see what they are looking for. So 2.1, they say that we have to calculate the coordinate of C if B it is equals to 1. So remember, whenever you are given one root there, you are going to do what? You're not going to use that formula f of x is equals to x minus x1. You're not going to use that. You only use that formula if the root are given. You only have one root there. So it means that if you only have one root, remember that formula says what? Is remember that your original function. First, let me write down your original function. Let me see where I can check this. Remember, we need to calculate c. So you are given f of x, which is simply x cubed, negative x cubed plus 5x squared plus 8x minus 12. So remember, when you have one root, it means now you have factorized what? Your cubic function. It means now you are left with what? If you factorize your function, let this be 0 when you want to calculate for x. We know only x1, so x1 is simply negative 1. Remember, we just take it the opposite of what we are seeing here. If it was negative 2, we place what? Positive 2 here. So since it is positive 2, we place what here? Negative 1. Or if it is positive 1, we place negative 1 there. So it means what we have now, we are left with just what? The quadratic function or the parabola. Remember, guys, always when you factor out the first root, what you are left with is just the parabola or a quadratic function. So if you factor out or factorize or have the two roots, now you're left with what? Just a straight line. So now, to find this value of, remember this is a, sorry for that, this is ax squared plus bx plus c. To find a and c is just very simple. You just look at this coefficient and the last term there, or the last term there. So it means now your a and x squared, those one are very simple or so easy to find them. You just say x times this one has to give you this one. It means x times negative x squared will give you what? A negative x cubed. And then a negative 1 times this part here, the last part there, will give you what? This part. So since it is negative and you have a negative here, it means you just need a positive 12. When you multiply this and this will give you that. So now guys, you just have to solve for bx. There are two methods to solve for bx. You can simply use what we call the synthetic division, or you can simply use the linear method. Now, the linear method, you just use what you have there. But first, let me show you what is there. Remember answering 2.1, question 2.1. Let me first show you how to use the synthetic division. You draw something like this, and your factor is what? Is just 1. So meaning if you take 1 and place it everywhere there's x, you're going to have what? 0. So that becomes so easy. So now x minus 1 is your factor, but when you take it out, it's just a positive 1. So you simply take those coefficient in front of x. So it is negative 1 here to your original function. Negative 1 plus 5 plus 8 and then minus 12. And then simply drop the first one there, you'll have negative 1. And then say 1 times this, you'll have negative 1. And then plug it here, that's negative 1. So 5 minus 1, that's what? That's 4. So now 1 times 4 is what? Is 4. And then place it here. 8 plus 4 is what? Is a positive 12. So now 1 times 12 is what? It's just 12. And then you plus you just place it there. So negative 12 plus a negative or positive 12, you get 0. So whenever you have 0 there, this is you already know that you have done it correct. Whenever you have 0 for the last terms there, you just know that you have factorized correct. So if the last factorization there gives you 0, just know that you did it correctly. So now this becomes your A, your B, your C. So if you have to check what is A is negative what? 1. What is C? C is positive 12. What is B? B will be what? 4. So you just say, okay, now this is 0 into what? Into x minus 1 into minus x squared plus 4x plus 12. As already explained, when you factorize the last terms, they have to give you 0. And when you have 0 there, you just know that you have factorized it correctly. But once you start having not 0 or greater than 0 there, just know that something is wrong. So now we need to factorize this so that we can have linear equations there. So you have x minus 1. To factorize this, you just need 2 brackets. So you'll have x into x. You can see you have 12 there. Remember, this is negative there. This is negative. I hope you can see that one. So now let me just write it nice. You have negative x. You have a positive x there. So this negative x time is the negative. Let's say this has to give us 12. So let's say negative. What is this? Negative 6. 6 times, or let me say 4. Let me say 4. Which one can I take? Remember the factors of 12, guys. The factors of 12 is just you can use 6 times 2. You can also use what? You can also use 3 times 4. And you can also use what? 12 times what? Times 1. So these are the factors of 12 there. So now you have to check there that the middle part is 4x. So when you multiply and also subtract, you have to get what? The middle term. So if you say 6 times 12, they give you 12. 6 minus 2 is what? Is 4. So it means you have 6 here. And then have what here? And have a positive, or a negative 2. So that when you say negative x times a positive, or negative x times a negative 6, it's going to give you what? A positive 6x minus 2 is going to give you what? Positive 4. And then this time that will give you that. So it means now, therefore, you'll have what? You'll have x1 to be 1, x2 to be, let's see, take that, you'll have -2, and then x3 will be just 6. So it means at A you have -2, B you have 1, C is simply 6. So now therefore they needed the coordinate of C, so C is simply 6 and 0. So Y is 0 there. And you can come back and say C, it is simply 6 and 0. So now they say now determine the coordinate of E. The coordinate of E, if you have to check there, it is what? The turning point. So you have to know what's happening at the turning point. Remember, the turning point, the gradient is what? Is simply 0 there. So the first derivative is equals to 0. So now let me see, let me use this one. So let me just use this one. So this is 2.2. We are answering 2.2. So we need to find the what? the coordinate of E. Now, to find the coordinate of E, guys, we have to check there. This is the turning point, and this is also the turning point. So we know that the first derivative at the turning point is simply what? 0 there. So the gradient is simply 0, guys. There. No? So it means we're just going to take the first derivative of our function and then equate to what? To 0. So taking the derivative of this using the power rule, you'll have -3x squared plus 8. You see why we should learn part 1 of differential, so that we know how to take the derivatives. So plus 8 and then it's equals to what? It's equals to 0 there. So now you just need to solve for x in here. So to solve for x here, you'll say now or you can simply multiply both sides by negative, or just keep it as it is. So you'll have this is -3x into x, and then you just need the factors of 8. The factors of 8 is 4 times 2. But remember, you have this 3 there again, and you also have 8 times 1. This is going to give you 80 there. So now, if you say 3 times 4 is going to give you what? 12. Then it's going to give you 12, and then when you say 12 minus 2, it's going to give you what? It's going to give you this 10 there. So it means you just need the 4 and you just need what? The 2. So 3 times this will give you a positive 12. And then just simply subtract there, you get that. So when you solve this, you say -3x is simply 2 divided both sides by negative. So it means therefore x is simply -2 all over 3. So this is x1, and your x2 is simply 4. So it means that at E there, the x coordinate is what? Is 4, or the critical value is 4 there. So therefore the value of the coordinate of E will be 4, and at F is equals to 4. So now let's go and find F at S equals to 4. So now we're going to evaluate this, guys. If you have to check, E is to the positive right side, né? Meaning that at E you'll have a positive x intercept, or a positive value of what? Of your critical point. So you cannot take -2 over 3. It means that -2 over 3 is just this one here. It's just the critical point of what? Of this left side there, yeah? Where it is concave up. So it means you're just going to evaluate your function at x is equals to 4, and we are going to find out what is y there. So you're just going to replace everywhere there is x with 4. So you're going to say 4 cubed, and then plus 5 into 4 squared, and then plus 8 into 2 minus 12. So let's see what is that. So now you'll have what? You'll have negative 4 into cubed, and then you have positive 5, and then 4, and then squared, and then you have 8 multiplied by 2 minus 12. So sorry for that. So it means that the corresponding y value, it is simply what? A positive 20 there. And you have to confirm, guys, if you have you did it correctly. So this negative into that, you left that, and then this is even if you protect it, guys, still be you still get the same thing now. So let me show you. It would be like, hey, what's really happening there? Still be the same thing now. So you see, you have that 5 into that, you have that into that, so that's going to give you a positive 20. So when x is 4, y is what? Is simply 20. So therefore, e, it is simply what? 4 and what? And 20. So you can come back and say, this will give you what? E into 4 and then 20 then. So now the next question is to, let me use another curve. So the next question is to calculate the values for which x will be concave up. Remember, guys, that concavity depends on the second derivative. So since they said concave up, you're just going to say the second derivative is what? Is simply greater than 0. This is when your function will be concave up. So concavity depends on second derivative. So this was our first derivative, no? So we're just going to say equation, what is that? 2.3. You're just going to take the second derivative. The first derivative, remember, this is the first derivative. It is negative 3x squared plus 10x plus 8. So simply now take the second derivative. So the second derivative, you'll have negative 3x squared, not negative 3x squared, sorry. You drop the exponent, multiply it with your base. This is 6x plus 10. And remember that the second derivative has to be what? Greater than 0 for it to be concave up. So negative 6x plus 10 is your second derivative. It has to be greater than 0. And then you solve for x here. You can simply take this term to your right, or simply keep the negative 6x there. Take this to your right, you'll have negative 10. And then divide both sides by negative 6x, negative 6. Negative 6, not 6x. Remember, we're solving for x. So this simply gonna be a positive there. So remember, guys, when you divide by negative throughout, yeah, the inequality sign changes from being greater than to what? To being less than. So therefore, x is less than what? Let's see. Let's find the factor that we can use. 2 goes into 10 5 times. 2 goes into 6 3 times. So the answer is what? Is simply x has to be less than 5 all over 3 for it to be concave up. And you can see that if 5 all over 3 is somewhere here or somewhere here, yeah, your function start to be what? To be concave up like that. And this makes sense that x has to be greater than these numbers going to the left there. So that's your answer there, guys. You're just going to say that therefore x has to be simply less than 5 all over 3. So now the next question, they say that you have to calculate the length of OG if the tangent to the curve at t, it is parallel to what? It is parallel to the tangent to curve at d. So that's very simple, guys. They say that now you have what? You have a tangent at what? At t. So you simply, let me just try again. So this is the tangent. You have a tangent at P, and you also have another tangent at D. So they are saying that these two lines are what? Are parallel. What do you know about two lines that are parallel? They have what? Equal gradient. They said it here that T is parallel to the tangent at D. The tangent at T is parallel to the tangent at D. So this is the tangent at D when x is what? Is 0 there. Remember that at D, I told you that This is just the -4, which is that -12, which is just the y-intercept, where the function cuts the x-axis. So this is -12. If you are to coordinate it, this is 0 and -12. So now let's find the gradient at negative or at d then, since we don't know much about t, guys. So this is question 2.4. So just going to say, okay, we know that this that at d there we have 0 and -12. So let's say what is the gradient at d? We're going to say, let's take the first derivative. The first derivative is what? Is -3x squared plus 10x plus 8. Yeah? This is the first derivative. It tells us about the gradient. We can find a gradient to any point to this curve. At E, at T, at C, at D, at A. Yeah? Using this first derivative, guys. Using what? The first derivative. It tells you about the gradient everywhere to your curve. Yeah? So now let's try to find the gradient at what? At x is equals to 0. Remember, you simply substitute in the place of x with what? With 0 there. Then the value of x that you have, this is x and y. So you simply say, okay, what is the gradient at x is equals to 0 there? Yeah? So this is going to give you what? -3 into 0 and then squared plus 10 into 0 plus 8. This will go away. So therefore, the gradient at x is equals to 0 is simply what? A positive. And this makes sense. You can see the slope. It is sloping upwards. Yeah? Meaning it is giving you what? A positive slope there. And it is increasing. So it means now this is the gradient at what? At d. Remember, this is the gradient at d. And we are told that d is also parallel, or d is parallel to t. So therefore, the gradient at what? At t there. I can call it tm. The gradient at t is going to be what? A positive 8, not a -8. It's going to be what? A positive 8. So what are you going to do for us to find the coordinate of of t, so that we can find the coordinate of g? And then from there, we know from O to G would be that length. From O to G would be that g that we will have found here. So now that's so easy, guys. Remember, we have the gradient at what? At t. So if we can say that, okay, remember, we can find the gradient at any point to this curve. So we're just going to say, okay, this is our first derivative. This is our first derivative. No? Let me just write it like this. This is our first derivative, -3x squared plus what? Plus 10x plus 8. This is what? Our gradient. So now let's equate it to the gradient of what? Of 8, of t there. Because we know that where the tangent happens, the gradient of the curve and the gradient of what? Of the tangent, they are exactly the same, guys. Mark my words again. The gradient of what? The tangent and the gradient of the graph, that they are exactly the same at that point. Yeah? It can be x is equals to a. A can be any number, a constant. It can be 2, it can be 4, it can be 6, it can be -2. So you just have to know that the gradient. Why am I saying this? Okay, let me emphasize here. Why am I saying this? I'm just going to use so I'm just going to say now the gradient of a curve is the same as the gradient of the tangent at only at that point, guys. At point x is equals to a, since we don't know x, so you say x is equals to a. That a stands for any constant there that you can ever have. So now we equate their gradient, because we know when the tangent happens, they have what? Equal gradient. So we're going to find the value of x. So what is the value of x at that point. So equating those two, it means now this and this will rationalize when you take this to what? To your left. So you just have left with what? With negative x squared plus 10x, which is equals to 0. So simply take out x, since it's just a factor there, x is everywhere there, so you have negative 3x plus 10, which is equals to 0. So x1 is simply 0, and then negative 3x is equals to negative 10x. So divide both sides by negative 3. So therefore x is simply positive 10 all over 3. So this is where the tangent happens. At what? At 8 all over 3. So this is simply 8 all over 3. And 8 all over 3, I think, is approximately 3.33, something like that. Yeah? So 10 over 3, not 8.3. So this is 10 over 3, guys. So at G, this is 10 all over 3, which is approximately 3.33. So remember, why did I say that G is also 10 over 3? Remember that T is perpendicular to what? To OG, meaning that it is just a vertical line, guys. It's just a vertical line that bisects at what? At X, or at it bisects the x-axis there. So it means that the x at T is the same as the x at G. You're not changing. It's not like we drew a line that's and then say this is G and then T is somewhere there. So those are no longer what? Are no longer perpendicular to each other. So once they are perpendicular to each other, the x value is what? Is the same there. So it means x is simply what? 10 over 3. But you're not done, guys. They said that calculate the length of OG. So where's O? O is here, and this is just the origin. From 0 to G, what is the length there? It is just 10 over 3. So just going to say, therefore, length OG is simply what? 10 all over 3 units. Remember, length has 12 units. So units there. So this will be your answers. So now let's take a look at the next question. This is 2.5. They say that we have to determine the value of m if y is equal to mx intersect f perpendicularly at x is equal to 5. What do we know about when two lines intersect each other perpendicular? We know that the product of their gradient is what? Is simply -1. When you have two lines that bisect, or what is this? When you have two lines, guys, that cut each other or bisect each other perpendicularly, they have what? The product of their gradient is simply -1. So what you're going to do there is to say this is determine the value of m if this straight line intersect f perpendicularly, meaning something like this. It has to form a 90-degree perpendicularly at x is equal to 5. So x is equal to 5 is somewhere here. And then you can just imagine a line that cuts like that, or a line that cuts like that. I don't know how it looks like, but it has to be perpendicular to the f there. So what you're going to do, guys, is to find what? The gradient of what? Your f at x is equal to 5 there. So you're just going to say, okay, where can I write this? Let me just squeeze it here, guys. So this is question what? 2.5, question 2.5. So just going to say, remember the first derivative is all about the gradient. So the first derivative is just this part that we have there. So this is -3 squared plus 10x plus 8, and say at x is equal to 5, what is the gradient there? So at x is equal to 5, let's see what is the gradient. Remember, I told you that this equation, the first derivative can give you the gradient to what? To your function, to any point. It can give you the gradient to function at any point there. So you can get any gradient that you want to that or to your function at any x value there. So now in this case is what is 5. We are looking or trying to find the gradient at x is equals to 5. So you can use this equation to find any gradient as at x is equals to a, which can be any constant. So now let's see what is that. So now this is going to be what? Let me just erase that. So this is negative 3 into 5 and then squared plus plus 10 into 5 and then plus 8. So the gradient is negative 17 at x is equals to 5. So the gradient at x is equals to 5 is simply what? Negative 17. How can I take this? This is negative 17 there. So it means now this gradient is something like this, guys. A line that looks more like this. That has a negative slope. And then it's going to pass or cut perpendicularly there to your function. But you're not done. This is the gradient at x is equals to negative at x is equals to 5. So remember that whenever you have a straight line that is perpendicular to your function there, the product of the gradient is what? Is simply negative 1. So you have what? The gradient of the first or you have the first gradient there at x is equals to 5, which is what? Negative 17. It's like this, guys. Let me picture it for you. Let's say at x is equals to 5. This is where the what? The intersection happens. So let's say that you know the gradient of this line, which is m2, and you're looking for the gradient of m1, and they cut perpendicular to each other. You know the product of the gradient is what? Is simply negative 1. So you know this gradient to be what? Negative 17. So to find this, you use this formula. So you're just going to say negative 17 times m2. So this means that you just divide both sides by negative 17, negative 17. So now this becomes positive. So therefore, m2 is simply what? 1 all over 17. So they say determine the value of m, just m, the gradient. So therefore, m is simply what? 1 all over 17. And this will be your answer. Since it is perpendicular to f at x is equals to 5. So I hope you understand, guys. So now let's take a look at this question. This is northwest. This is northwest. So now they say that the graph f of x is equals to a raised to an exponent of 3 plus bx squared has a stationary point at p and o there. So this is the maximum. This is what? The minimum. Like that. So now let's see the first question. The first question is 3.1. They said that we have to prove the value of a and the value of b there. So this is question 3.1. So guys, remember that at the turning point, the first derivative, which is the gradient, is equal to what? 0. You cannot use this point to help you calculate the value of a, or the value of b, because we know that this point is just the origin. 0 is 0. If you plug x is equals to 0, x is equals to 0, you're not going to find the value of a and b. So you're just going to use p to help you find the value of a and also help you to find what? The value of b. So the first thing you should do is to say p. Where's p? P is a minimum there. It's a turning point, meaning the gradient there is what? Is simply equals to 0 there. Now remember the turning point, the gradient, which is the first derivative, is equals to 0. So I'm going to say let's take the first derivative there. And remember, we know the x value there. At x is equals to 2, the gradient is going to be 0, guys. Trust me. So now let's take the first derivative. The first derivative, if we take the first derivative of this function there, you'll have what? 3a x squared plus 2bx. This has to be what? Equals to 0. So now remember, we have to place in this the first derivative in the place of x with what? With 2 there. So you'll have 3a into 2 x squared plus 2 b into 2, and then this has to be 0. So now 2 times or 2 squared, that's 4 times 3, that's like 12. So you have 12a plus what? This will give you 4b has to be equals to 0, and you can term this what? Equation 1. To find equation 2 is to also remember that you have the y coordinate, né? Meaning that this p is also a pointer to your function there. So you can say to your original function there, in the place of x, put 2. This gives you what? Negative 1 all over 3. So it means now you're going to say a at what? At 2 into 3. I'm substituting to the original function. Plus b into 2 and then squared. This has to be equals to what? Negative 1 all over 3. So now to solve this, 2 cubed, that's 8a. 2 squared, that's 4b. This has to equals to what? Negative 1 all over 3. And this has to be our equation 2. So if I were to check between 12 and 8, which one is which one is bigger between 12 and 8? You'll agree that 12 is what is larger than 8. So meaning you're just going to say equation 1 minus equation 2. So it means 12 minus 8, a is going to give you what? 4. Ne? 4. This is going to be 4a into what? 4b minus 4b, or 4b minus 4b. This is going to give you 0. So now 0 minus 1 over 3 is going to give you what? A positive. Remember, it's equals to positive what? 1 all over 3, guys. Remember, don't forget about this. It's equals to. So I'm just teaching this and then simultaneously just writing down, ne? Not showing you or just explaining J, and you know where it comes about, ne? So now to find a, we just simply what? Divide both sides by what? By this 4. So divide by 4, this is the same as multiplying by 1 all over 4. So this and this rationalizes, so therefore a is simply what? 1 all over 12. 3 times 4 is 12. So this is the value of a. So now to find the b, you say now sub a equals to 1 all over 12 into which equation? Equation 1, since I see I have 0 there. So this will be 12 into what? 1 all over 12 plus 4b, which is equals to 0. This and this rationalize. You'll have 1 plus 4b, and then it's equals to 0. Take this to your right, you'll have 4b equaling negative 1. Divide both sides by 4. Therefore, your b will be a negative 1 all over 4. And if you have to check, that's what we got there. It is the same thing. So now, let's take a look at the next question. So now let me just use this one. So now they say in 3.2, for which values of x will f be concave down? So guys, I will say it again. Concavity depends on the second derivative. Now, down depends on the equality sign, which is what? Less than 0 there. So whenever you hear about concave down, the second derivative is what? Is less than 0. When you hear about concave up, the second derivative is greater than 0. Same as what we did here. This is concave up, the second derivative is what? Greater than 0. Concave down, the second derivative is what? Is less than 0. Since concavity depends on what? On the second derivative. So it means now we're just going to take the first derivative and then the second derivative. So now answering 3.2. So we first write our function. This is 1 all over 12 x cubed minus 1 all over 4 into x squared. So take the first derivative of this function. You'll have 3 divided by 12. That's like 1 into all over 4. So 3 goes into itself once to 12 goes 4 times. So 3, 6, 9, 12. That's 4 times. And then you'll have what? X squared like that. Oh, yeah, it is true. 3 times that will give you that case. I'm using the power rule, remember. 2 divided by 4. This is this 2 cannot go, or 2 or 4 cannot go into 2, guys. So you say what? 2 goes into itself once to 4. How many times? 2 times. So this is x. Yeah? So now when you take the second derivative, you'll have what now? You'll have just a half. 2 goes into to itself once to 4. How many times? 2 times. And then you just have x. And then 1 goes into itself once to 2. How many times? 2 times. So you have this. So now, remember, this is what? Your second derivative. You have to let your second derivative to be what? Less than 0. So you say 1 all over 2 into x minus 1 all over 2 to be less than 0. So 1 all over 2x has to be less than 1 all over 2. When you divide both sides by x, it means x has to be less than 1. So this is your answer there. So remember, this is concave down. So let's try to picture this. This is concave down. No? This is what? Concave down and then concave up. So concave down start to happen from here up to point of inflection there. So this is concave down. And this is true that if x is just here, going to the left, you'll have concave down. Going to negative infinity, you'll have what? You'll have just concave down. So therefore, x has to be less than 1. And that would be your answer. Or you can say x is an element from negative infinity to what? To 1. That would be, you are still applicable, guys. So now let's take a look at the next question. This is 3.3. This is determine the equation of a tangent to f at x is equals to negative 2 in the form Tn is equals to mx plus n. In this case, it is no longer y is equals to mx plus c. Understand? So now this way we have to determine the equation of a tangent. So guys, whenever you hear about the tangent, a tangent has what? A gradient. So now we are going to find that gradient at negative 2. But how do we find the gradient of that tangent? We are going to say, okay, this tangent is a tangent to what? To our function f of x. So now, answering question 3.2. So we're going to say what? Remember, the first derivative is all about the gradient. So we take the first derivative of this function. We're going to have 1 all over, what is that? It's 1 all over 4. Remember, it is this one. The first derivative is 1 all over 4 into x. So guys, always take the first derivative, take the second derivative, and then this is your first derivative, remember, from the original function. So you'll have x squared minus 1 all over 2. So I'm just copying what we did here, yeah, in our last question. So now this is the first derivative. Remember, I told you about when you take the first derivative, it's always going to give you any gradient that you want to this function at any x value. Understand? In this case, it is what? At x is equals to negative 2. So let's see the gradient at x is equals to negative 2. So this is 1 all over 4 into negative 2x squared minus 1 all over 2, negative 2. And then let me see what we have there. So this is what? This is 1 all over 4 minus 2 squared minus 1 all over 2 and then minus 2. So the answer is simply what? A positive 2. So the gradient at negative 2 or at x is equal to negative 2 is simply what? 2. So therefore, this will give you what? The gradient of this tangent also. Because the gradient of the tangent and the gradient of the graph, they are exactly the same at that point. In this case is what? X is equal to negative 2. So therefore, this tangent here would be what now? Tn is simply what? your m now it is 2x plus n. To find n, you use this point and see, okay, remember this point here, x is equal to minus 2. It is also what? Or this x minus 2, it is also to the curve. It is also a point to a curve. So you're just going to say, what is the y value when x is negative 2? So at f is equal to negative 2. What is the y value? So you're just going to say this is remember your a, it is 1 all over 12, and then x, remember we just make the substitution simultaneously. So this is negative 2 and then what, cubed, and then it's supposed to be negative 1 all over 4 and then x squared, né? So this is negative 2 squared. So remember, this is what I mean, I'm making the substitution there. So now let's see what is that. So now this is 1 all over 12 into negative 2 cubed. I'm trying to find the corresponding y value. Since I have x, so 4 into negative 2 and then squared. So this is negative 5 all over 3. So therefore, when f is, or when x is negative 2, y is negative 5 all over 3. Was it negative 5 all over 3? Let me confirm. Yes. So now, this is a point now. So we can say this is a point now. Negative 2 and what? And negative 5 all over 3. So now we can use this point to find what? To find the value of n. So to this equation, remember Tn is the same as y is equal to mx and then plus n. So we're just going to say, okay, your y, it is what? Negative 5 over 3. So negative 5 all over 3 into what? Into your m is what? Is 2. What about your x? Negative 2 and then plus n. So this will give us negative 5 all over 3, which is equal to negative 4 plus n. So now when you take this to your left, or left, yes, left, you have minus 5 all over 3 into a positive 4. So this will give you 3 into negative 5, and then plus 12. This will give you negative 7, ne? This is 7. Negative 7. So this will be what? Negative 7. 7, 8, 9, 10, 11, 12. Yes, 7 all over 3, guys. So this is, what is this? You have negative 7 all over 3. Then this is equals to n. So therefore, your Tn will be what? Tn is simply what? The gradient is 2, and then x. Your n is what? Is minus 7 all over 3. So now let me erase this. So that's what we have there. Or you want us to confirm? I'm so tired. You want us to confirm? Let me show you. And then plus 4. This is a positive. Remember, you'll have a negative 5, guys. This is negative 5 plus 12. It give you what? It will give you a positive value. Not what I wrote there. A positive value. But 7 over 3 still remains, né? So this will be your equation, guys. So for that, just that you really tired, né? But don't worry, we'll manage. So now, 3.4, they say use the graph to determine the value of k for which, what? This is your original function. Remember, now this is your f of x. This is your f of x. A didn't change. This is a. B didn't change. But now they are adding k there. And then it's equals to 0. So it means this is the same as f of x is equals to what? K. What is f of x? F of x is simply y is equals to k. But we are not done. We haven't solved anything there. So let's see. Use the graph to determine the value of k for which your function, and then minus k will have 3 real roots. So guys, remember now is f of x is equals to k. So they're asking, where are we going to have three roots? No? Three roots when y is equals to k. Or I can say the f of x is equals to k. This is the intersection of what? Of your function f of x with what? With k. So the root of this equation here, it is going to be what? The intersection of f with k. In this case, guys, k, it is what? A constant. Y is equals to k. It is what? A constant. So it means now for us to have what? Three roots. Remember, I told you that for us to have a three roots, this equation here is what? Is going to be what? The intersection of f of x with what? With k. So if we have an intersection here, if we have an intersection from here, that's one root, and then here, that's going to be what? Two roots. So if we have an intersection here, and then here, and then here, how many are they? There are three. So if you have an intersection here, and then at the what? The minimum, how many are they? There are two. So at the top, you have two roots. The bottom, which is the minimum, when your k, remember your k is a line, guys. Let me just show you like this. A k is a line, y is equals to what? K, which is a constant. So if we also have it at the maximum there, this is y is equals to k. We know they gave us what? Two roots. And also here they gave us what? Two roots. But when k is between the maximum and the minimum, just in between there, you'll have what? You'll have three roots. So meaning, remember, I told you about the roots of your function. This is where the intersection happens. So if k is a line that we use, that we are going to use in order to move it to this equation horizontal, not horizontal but vertical. Yes, vertically, top and bottom, like that. It's a shift, horizontal shift. Is it a horizontal shift? Yes, a horizontal shift like that. Think of a K like a line that we can move it top and then down. Top and then down like that. So that's K there. So if K can be between these 2 points, guys, I hope you can understand. If K can be between the maximum and the minimum, and then let's say K, let me see what we can use there. So let's say this is the line K. That's the line K there. You see, it will intersect here 1, and then 2 here, and then 3. How many roots do you have? There are 3. So what is the maximum there? The maximum is just the origin. But we need the y value since y is equals to k. So k is just the constant, the y value. So we're moving the graph horizontal, top and bottom, like that. Not vertically, not a vertical line, but a horizontal line. K is just the horizontal line. So just going to check the y intercept there, or the y values at the maximum and the minimum. So just going to say, okay, k has to be what? Has to be less than 0. If k can be below the maximum, it will lie between there. But the same k has to be greater than what? Greater than this negative 1 all over 3. Why greater than? Guys, the meaning of greater than negative 1 over 3, does it mean now k will lie below the minimum, or like exceed and goes to negative infinity or whatever, or what, negative 8, negative 7 there? It doesn't mean that, guys. If k is greater than negative 1 over 3, remember, if k is greater than negative 1 over 3, let me show you what is negative 1 over 3. Negative 1 over 3 is, what is this? Is 0.3333. So this is negative 0.3333. So if you can have negative 0.333, let's say k is what is negative 0.2222. So is this number greater than this number? That's correct. So it means k has to fall what? Above this number here. Understand? So k has to be between the maximum and what? The minimum, for it to have what? 3 real roots. So this will be your answer. So therefore, k has to be what? Between these two numbers. Or you can say that k is an element from what? From negative 1 over 3 to what? To 0. And the 0 is not included. And this will be your answer. Please make sure that you understand this, guys. We are saying k is a constant. Yeah? It has to lie between the maximum and the minimum for it to have what? For it, remember, this f is f of x with what? With k. So this is the intersection of f of x with k. This is what? Your f of x, and this is the k. So with k, they are going to lie between these 2 points, the maximum and the minimum, for it to have what? 3 real roots. That's the intersection of what? Of f of x with k. So now let's take a look at the next question. So I hope you understand, guys. Nah? Make sure that you understand that. I'm so tired. It's 4 a.m. in the morning. Yo. So now they say that the sketch below is the graph of what? Of f prime. What is f prime? This is the derivative, nah? Of f of x. So since it is the derivative of f of x, let's take the derivative of this. When we take the first derivative of this, we're going to have what? Negative 6x squared minus 6x plus a positive 12. It means now this positive 12, it is what? The y-intercept of what? Of your first derivative. So at a, the y-intercept happened here. So this is negative 12. Understand? So now this is a square, not a square, but a parabola or a quadratic function. And the value of a is less than 0, meaning you have a frown face. If we can put the eyes and this is the mouth, you can see that our graph is a frown face like that. So that's the first derivative. This is a point A and A. Okay, point A, B, C are the intercept of what? Of your first derivative, which is the quadratic. So the first question is to write down the coordinate of A. You see this thing write down, meaning it is given. So A is simply 0 and negative 12. They didn't say write down the Y, guys. They say coordinate. So you say 0 and negative 12. So now the next question, determine the coordinate of B and C. The coordinate of B and C is what? The x-intercept of what? Of your quadratic function or this parabola. So just going to solve this. We let this function, we treat it now as what? As a function of y, like y is equals to. Yeah? So we let this be 0 and solve this the x-intercept of this function there. So this is going to be what here? This negative x into that minus 6x plus 12. So when we let this equals to 0, let's divide both sides by negative 12 first. Yeah, let's reduce the terms. So let's divide both sides by negative 6. You do it on your right side, you have to do it also on the left side. So you have 0. This will give you a positive, so this is x squared. This will give you a positive plus x. This will give you a negative and then 2. So then to solve this, you simply have x 2 1 negative, or this positive and then this negative. So this time that will give you that, this time that will give you negative x minus that will give you that. So simply x1 is simply negative 2, and then x2 is simply 1. So this means at B you have negative 2, and then C you have 1 there. So now you can come back and say B is what? Negative 2, Y is 0, and then you can say union like this, meaning and. Ne? Then C is also what? It's also 1, or it is 1 and 0 there. So now guys, let's take a look at the next question. Which points on the graph of f will exactly have the same x values as B? So remember guys that this function here, it is what? The first derivative. It is the gradient of what? Of your function f of x, the original functions. So when you take the first derivative, guys, Now you have what? You have what is this? You have a quadratic function. So it means now your cubic function, since the value of a is less than 0, this -2, check, is -2 is less than 0, né? So it means you'll have a function that starts by what? By decreasing, né? By decreasing and then increase. It's going to cut that what? At positive 20. 11 x y-intercept at 20, and then a maximum at what? At 2, and then like that. So this shows you what? I want to show you something. Let's stay with me. When you take, this is f of x, when you take the first derivative, you are actually finding the gradient of what? Your original function. So you're saying, where is your function increasing or decreasing? Yeah? So this shape here, you can see it is what? It is sloping like that. So it tells you about the gradient, meaning the gradient is positive between these 2 points. You can see from -2 to +1. The gradient is what? Is positive there, meaning the function, the f prime of x is above what? The x-axis. It's above what? The x-axis. So it tells you now the gradient is what? Is positive there. So once f start to be below the x-axis, now it tells you the gradient is what? Is negative. The gradient of what? The original function, or the function, guys. The original function is what? Is negative now, or is decreasing. Understand? So now they're asking us if these points, your B and C, what are they? So they say which points on the graph F will exactly have the same x values as B. What are these points to our original function? They're saying to F. They are what? The critical points. So the answer is critical points there. The critical points, guys, remember, it is the x-intercept at the turning point. So this is the critical points. Or you can say values of f of x. So you can see those will give you what? The critical point of your f of x. And you'll have a repeating rules there. So now, they say in 4.1.4, they say that for which values of x would be f increasing. Now I drew the graph of f. They say, where is f increasing? You can see, I told you that f is increasing between these 2 points. Ne? This first derivative, guys, tells you about the gradient. Ne? About the gradient of what? Your original function. You can see that the gradient of the original function between these 2 points is what? Is positive. It is sloping upwards like that. So between those 2 points, your function is what? Is increasing there. So you can say now, therefore, x has to be between what? 1, and x has to be greater than what? -2. Or you can say that x is an element from -2 to what? To 1. That will also be applicable, guys. I hope you understand. Né? So x has to lie between these 2 points. Not equals to those 2 points, but just lie between those 2 points. So now, the next question is 4.1.5. Determine the y-coordinate of the point of inflection. The point of inflection, guys, is the second derivative equaling 0. So we have to first take the first derivative. So this is question what? 4.5. Yeah? So question 4.1.5. So the first derivative is all about the gradient. So the first derivative will give us what? Negative 6x squared minus 6x plus 12. Then take the second derivative, is all about concavity, and it's also about the point of inflection. Remember, the point of inflection is where your graph is either concave up or concave down. So this happens at the point of inflection. When you take the second derivative, you have negative 12x minus 6. Equate this to 0. Remember, I said equate this to 0, and then you do what? You solve for x. So this is negative 12x minus 6. Take this to your left, or take this to your right, or take this negative 12x to your left. So I'm just going to take this to the left. So you left that, divide both sides by 12. So this rationalize, so you left x into that. So 6 goes into itself once to 12. How many times? Two times. or twice. So x is negative 1 over 2, but you're not done. This is determine the y coordinate of the point of inflection of x of f. This is the x coordinate of what of the point of inflection of f. So now we're just going to say let's find the y corresponding y value of this point of inflection. So at x is equal to negative 1 over 2. What is y? So we're just going to say, excuse, we're going to make the substitution here. If in the place of x, we are replacing with what? With negative 1 all over 3. 1 over 2, I mean a half. So we know we don't like wasting time. So you're just simply going to say this is negative 2. Guys, this is a meaning in math. You're saying you're evaluating your function at negative 1 over 2. No? That's it. It means something there. No? It has a meaning there, guys. So you don't have to like waste time also wanting to show them like you are placing a negative half in place of x. Don't waste time. So now you'll have a negative half, and then this is squared, and then plus 12 into what? Into negative a half, and then what? Plus 20 there. So the answer is what? Is 27 all over 2, which is what? 13.5. 27 all over 2. So this is 27 all over 2, which is approximately 13.5. So you're not done, guys. They say that determine the y coordinate of the point of inflection. So you can say y is simply what? Is simply 13.5, which is the same as what? The 27 all over 2, like that. Yeah? So that's it with that question there. So now let's take a look at the last one for this one. So for this question, so they say that we have a tangent at point P, and then okay, they say the tangent at point P to the curve is given by this. So they say this is a tangent at what? At to the curve at this point. So they say it intersects the x-axis at point R, okay, at point R, such that line PT is perpendicular to the x-axis. Okay, PT to be perpendicular to the x-axis with T on the x-axis, so determine the length of RT. So guys, since this said that this is a tangent and they intersect the x-axis at point R, we can find what? The y-intercept at when, remember, at the x-axis, this is when y it is 0. So we can find that x-intercept when y is what? Is 0 there, so that we can find R. So let's see if that makes sense. So that's 0 in the place of y, then minus x squared, the minus 1. Take this to your left, you'll have 1 minus x into that. And you can see we cannot solve this because now you'll have negative 1 into x squared. Can you take the square root of a negative number? The answer is no. Yeah? So it means there is misinterpretation here. Let's read it again. Let's read again. The tangent at P is what? Is 3. Okay, the tangent at P, which is the coordinate of what? Of 3 and negative 10, to the curve. So this tangent is to the curve. Yeah? And it is given by what? By y, which is negative x minus 1. So this tangent has a what? An equation of y is equals to negative x squared minus 1. Make sure you understand that, guys. Let's read it again. The tangent at P to the curve is given by, you heard that? The tangent is given by what? By this. Does it make sense? Because now, remember, a tangent has the standard form of what? Of a y is equals to mx plus c. But now they're telling us that this tangent is y is equals to minus x squared minus 1. And this is actually what? A parabola. Yeah? This is a parabola. Or a what? A quadratic function. Yeah? So does that make sense? I think there is misinterpretation. Yeah? So, guys, there is an error to this question. But if you're too smart, you will not agree that this is a tangent, because now this is not the tangent, it's actually a parabola. So what we are going to do is to say, okay, what if this tangent is the tangent to to our parabola? What if this tangent is the tangent to our parabola, which is the equation of of x minus or x squared minus 1? So what if this tangent is to this function there? Not worry, this tangent has an equation of that. So now let's go and deal with that. So first, let's try to sketch this function and see what's happening there. Since we know that we cannot solve for x, also it's not easy to find for y, but y is easy. It's just -1. Yeah? It's -1 there. When you let x be 0, y is -1. So this is where the intersection is. So, but let me show you how you deal with this. You just draw a small table, yeah? X and y. Just come up with your own value. -2, -1, 0, 1, and then 2. And then when we place -2 here, you'll have what? Since 2 is an even number, you'll have -4, -1. This will give you what? -5. You place -1, you'll have what? A -1 again, -1. This will give you what? A -2. You place 0, you get -1. You place 1, you get -2. You place 2, you get -5. Since 2 is an even number. So now let's go and sketch that. This is -1. Eh? This is -2. Let's say this is -5 here. So -5 matches with that with -2. And again, +2 matches with that -5. So let's say +2 is somewhere here. So this is 2, and it matches with that with -5 this side. And then a 1 matches with that with -2. Let's say -2 is somewhere here. So this is 1 and what? And -2. And again, -1 matches with that with -2. Let's say this is -1. And then it matches with that a +2. And then 0 and what? And -1 there. So it means now this is the function. This is actually what? Your parabola. And you can see the front face. Ne? It is what? A front face. It's not happy, because you can see like that. If you have a graph that looks like this, put the eyes there and then put the face. Is it smiling? Yeah, it is not. No? So there's a front face there. So now this is your function now. This is the function what? Y minus x squared minus 1. So now remember what I said. If you are too smart, you will have not skipped the question. You'll have stayed here and see what's really happening and disagree with what they're saying, that this is a equation of a tangent. That's impossible. No? So now let's read. They say that it intersects the x-axis. So what we are going to picture this is to say now there is a tangent to what? To this function. At what? At point P. What is P? P is they told that this is 3 and what? P is 3 and -10. So we're going to say there is a tangent to what? To this function at what? At 3 and -10. So now let's say this is 10. Yeah, -10. Yeah? So let's say P is somewhere here. This is 3 and what? And -10. And there is a tangent that is P there. And let's see where this tangent is heading. This tangent intersects the x-axis at point R. Okay. So let me use another color there. So we're going to say, okay, this is the tangent. It's going to cut to have a okay. We are going to have a tangent at point P, and then it's going to cut at what? At R, and then also there. So it means it cuts the x-axis what? At R. They told us that it intersects the x-axis at R, and then line PT is drawn perpendicular to the x-axis. So from P to T, it means this is T, so that it be what? Perpendicular to the x-axis. So it means this is 3. Also, the T x value there will be what? 3. Since PT is just what? A perpendicular line. So now they're saying what? They're saying with t on the x-axis. Now, with t on the x-axis, this is t on the x-axis. So now this is determine the length of RT. We need this length R to t. Now, even if we know what is 3 there, but what about this point R? So now that's easy. Now, I'll show you how we are going to deal with this. So you're going to say, okay, this is the tangent. The tangent is y is equals to mx plus c. I told you before that the gradient of the tangent and the gradient of the graph, they're exactly the same at that point. In this case, it's point what? P. So we're just going to take the first derivative of this function there. We know the first derivative is all about the gradient. So take the first derivative of that function. Let me just write this nice. So the first derivative of this function, this one, is going to give us what? Negative 2x, and then what? Just negative 2x. So now we want to find the gradient at that point P using the x value, guys. You always use the x value. Don't use the y. So you say at x is equals to 3. What is the gradient? Remember, I told you that when you take the derivative, now that expression that you have, it is going to give you any gradient that you want at any x value. Now, in this case is what is 3. We want the gradient at x is equals to 3. And the gradient is going to give us what? Negative 6. Does that make sense? It makes sense. If you have to check the line this y makes plus c, it's what? Sloping downwards. It has what? It's negative slope, meaning the gradient is what? Is negative. And this makes sense. So now you have what now? You have y is equals to negative 6x. Don't worry about the c, or we can say c. This c, remember, it always tells us about what? The x-intercept, where your straight line cuts the y-axis. So, do you need to find that? Yeah, you can try to find that by saying, okay, this is also a point, remember, to this function there. So you'll use that point and say, okay, this is going to be y is equals to negative 6x plus c, and then use that point P there. So what is y? Y is negative 10 into negative 6 into what? Into 3, and then plus c. This will give you a negative 18x. And then when you take 18 to this side, you'll have just 8, as you see. So you'll have negative 10 and then plus 18. This from 10 or from 18 remove 10, you'll have just 8. So that's the value of c there. So for those who are so curious, so that's the value of c. So it means that this, guys, remember, I'm not drawing to scale. It doesn't mean it has to cut there at negative 12. I was just making sure that you guys have to understand this. So this has to be a positive 8. It has to cut at 8 below positive 12 there. Understand? So now this is what you have. So from there, guys, remember, what was the question? We have to determine RT. So how do we find this, guys? Remember, now we have the equation y is equals to negative 6x plus 8. What is happening at R? We know at R we have the x value, but what about the y? The y is 0, because R is what? R is the x-axis, R is the point at the x-axis, meaning the y value, it is 0. So you're just going to say to your function, which is now your straight line. Remember, it cuts the x-axis at point R, which y is what? Your 0 there. Y is going to be 0. So you're going to find x. What is x when y is 0? You take this to the left, you left 6x, which is equals to what? The 8. You divide both sides by 6. Now, when you divide both sides by 6, you ask yourself, do you have a factor that you can use to 8? Okay, that's 2. 2 goes into 8 how many times? It goes 4 times. Now 2, 4, 6, 8. 4 times. What about to 6? It goes how many times? 2 to 6, it goes 3 times. 2 to 6 goes 3 times. And 4 divided by 2, this is just 2. It goes 3 times, not 2. Remember, 2 goes into 3. 2 goes into 6 3 times, guys, not 2, 3 times. And then to 4 to 8, 4 times. So this is x is equals to what? 4 all over 3. So now, you no longer have just x there. You have r, which is the coordinate there now. So you're just going to say, okay, now we have the coordinate of r. It is going to be what? The 4 all over 3. Don't worry about finding the y value there. No, it is 0. Now, they want us to find this length RT. If from the 0 to R it is 4 over 3, and from 0 to T it is 3, to find RT, you simply say the long one, there's from 0 or from the origin to T, that's what? That's 3. Minus from the origin to what? To OR, you'll find this length of what? Of that thing there. So I'm just going to say the length RT is going to be what? OT minus what? OR. OT, you know, from O to T is 3, minus O to R is this distance, or the length, 4 all over 3. So let's see what is the answer then. So now I'm just going to say the length RT. So now let's take that, or let me just use calculations here. This is something like this. So you say this is 3 into 9 minus 4. This is 5. You left 5 all over 3. So the answer is simply 5 all over 3. So that's your answer then. And we are done with that question. Guys, don't skip if you think or you see that the question has an error. Try by all means to work it out. You don't skip. If you skip, they're not going to give you anything. So you see, there was an error here. There was a misinterpretation. A tangent cannot have an order of 2. A tangent always has an order of what? Of 1, which is just the mx plus c. It's just a straight line. This is not the straight line, that's a parabola. Okay, so now let me see which pen that we can use. So now 5.1. 5.1. Now let's say that given the function f of x, which is equal to that x cubed minus 12x minus 16. This 16 tells you about what? The y-intercept. Always remember that. They said that calculated there in 5.1. I'm just going to say this is question 5.1.1. Calculate the turning point of f. Guys, you know the turning point. Once you have the turning point depends on the first derivative. Concavity depends on the second derivative. The turning point depends on the first derivative. So take the first derivative and then equate to 0. You know the gradient at the turning point is what? Is 0. So you equate to 0, take the first derivative of this. This is going to be what? 3x squared minus 12. This is what? 0. So now to solve for x, you simply say 3x squared is equal to what? 12. Divide both sides by 3. The 3 and the 3 rationalize, you have x squared is equal to what? 12. To that you have what is this? You have 4. 12 or 3 goes into 12 4 times. That 3, 6, 9, 12. So that's 4. 3, 6, 9, 12. That's 4. And then take the square root of this. Take the square root of this. Remember, when you take the square root, guys, you have plus and minus. So it means x is plus and minus what? Minus 2. So now, our x1 is either what? Negative 2. Our x2 is either what? A positive 2. They said that we have to find the coordinate, not the x coordinate. Not the x coordinate, but not the x-intercept, or the critical point, but you have to coordinate. So meaning you have to find the corresponding y value. So just going to say what is y, or evaluate your function at x is equal to negative 2. and then also evaluate your function at x is equal to what? 2. Remember, I told you you don't have to waste time trying to show them. Then just take out your calculator and simply place 2 and negative 2 in the place of x. Everywhere there's x. So you have something like this, then minus 16. This is 0, no? And then now let's place 2. This is negative 32. So you have 0, you have negative 32. Guys, remember, whenever you have 0, remember, whenever you want to calculate the x-intercept of your cubic function, you agree that you'll come up with any value, or you'll come up with or you'll start trying values between, let's say, plus minus 9, or plus minus 2, plus minus 3, plus minus 1, and substitute here to solve what? The x-intercept. That's what you will have done. Ne? So whenever you place them here and find that your function is what? Is just 0, that become what? Your factor. You agree, ne? It means that at x is equal to 2, you have what? That's your factor then, ne? X plus 2 is your factor, so that when you solve it, you'll have negative 2. So now this is your answer, but you're not done. This is coordinate. So you see, you can just say, since they said the turning point, you can say TP is what? Is negative 2, 0, and then you say union, meaning end, going down like that. Look, when you just read like pointing up, like is it cave up is or, right? So this is end. So this is 2, and then what? Negative 32, and they are done like that. So now the next question is to calculate the x-intercept. This is the reason why I spend time on negative 2. That whenever you want to calculate the x-intercept of your cubic function, you will try plugging in plus or minus 1, plus or minus 2, plus or minus 3, blah 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 blah. And then if you find that your function is equal to 0, that's your what? Your fact. So now they say calculate the x-intercept of R for 3 marks. So it means now we have a factor, né? Because now our function is what? Is 0 there. So since we have a factor, we are going to say, okay, where can I write this? Let me just see. I'm just going to squeeze it here. Now this is question 5.1.2. So now to find the x-intercept of that, you let y be 0, né? So this becomes your factor. Remember, if you substitute the 1 and then you find that this is equal to 0, this whole thing is equal to 0, it means now you have to say x minus 1 is what? The factor. This is the factor, right? So it means now, since x minus 2 is the one that gave us 0, or for our function to be 0, it means now x plus 2 is the factor. So it's that the opposite of what you substituted in the place of x, or what you replace in the place of x. So now I always tell you, now you'll be left with the parabola or quadratic function. And to find the value of a and c is very simple. You just look at the last term and the first term. Now, the first term is 1, so it means now a is just 1. So that when you say x times x squared, it can give you what? X cubed there. And then c, you just have to get into 16, you need how much? You just need 2 times 8. 2 times 8 will give you what? 16. But since it is negative 16, it means since here it is positive, you just need a negative there to get into that. To find the value of b, you can use the synthetic division. So the synthetic division, you know, it works like this. You're just going to say, you draw this thing and say you take what? The negative 2. Remember, the negative 2, when you place it there, it gives you 0, né? So you say the negative 2 and then place 1. You just take the coefficient of this. This is the negative 12. Those are the coefficient, and then 0 like that. So remember, it's supposed to be 1. So since you don't have the x squared, it means it is what? 0x squared. So the coefficient there is what? 0, followed by what? Minus 12, followed by what? Negative 16. So this is 1, 0, negative 12, minus 16. So drop the 1, always drop the 1, multiply it with this number, it will give you what? A negative 2. Place that negative 2, 0 minus 2, it give you what? A negative 2. This time is this, it gives you what? A positive 4. And then place it there. 4 minus this answer there, it will give you what? Remember, this is 16, not 6. When you place, this is a positive 4, remember. Negative times negative give you positive. So now, you sum the two, negative 12 plus 4. That's negative 8. This time is that, will give you what? A positive 16. And I already told you that whenever the last term gives you 0, just know that you have factorized it correct, or you have done it correct. So this becomes your A, your B, and C. Check. What is your C? Negative 8. What is your A? Positive 1. What is your B now? It's going to be what? A negative 2. So it means now you're just going to say this is 0 into x plus 2, then x squared, and then what is this? Minus 2x minus 8. So where can I take this? Let me see. I'm just going to take this side. Okay, guys. So you have 0 into x plus 5, 8, 2. And again, I'm just going to simultaneously factorize the inside. So I'm just going to open up the bracket. So you'll have x into x. You need the factors of 8 and then subtract them. They can that has to give you 2 or negative 2. So that's 4 and 2. 4 being negative, 2 being a positive there. So therefore, you say minus 4x minus minus 4x plus 2x will give you minus 2x. These times that will give you that. So therefore, when you solve for x, you'll have x1 to be negative 2, x2 to be 4, and then x3 to be what? A negative 2. I told you we have repeating roots. This is repeating roots. Yeah? Did I explain that? Did I explain that, guys? Explain there is a repeating roots, right? Oh, I didn't. It was the last question. So it means now since you have a negative 2 and a negative 2, it means you have what? Repeating roots there. So now, the first root that we got, this is negative 2. So at negative 2, you have repeating roots there. But they said calculate the x-intercept, just the x-intercept, not the x-coordinate, right? Just the x-intercept. So you say, this is for 3 marks. So you say x1 is negative 2, x2 is 4, and then x3 is what? Is negative 2. So is this correct? Did we factorize this correct? This time that gave us squared. This time this will give us 2x minus 4, give us negative that, and then that, yes. So now let's take a look at the next question. Oh, this is this one there. So now let me see, let me use this one now. So now they say y it is equals to what? Is equals to plus p is a tangent. Okay, y is equals to 15x plus p is a tangent. Yes, it makes sense now. You see, it makes sense because the order is just 1. To the graph of f. What is f? This f that we're given there. Calculate the x coordinate of the point of contact. You are given the gradient this time. If we can take the first derivative, you have what? The gradient, and then equate their gradient, you will find the point of what? Of contact there. So you're just going to take the derivative of that. It will give us 1 mark for taking the derivative of this. So this is 3x squared minus 12. And then this is the gradient. The gradient is what? Also 15 there. And this is also the gradient. So we want to find the coordinate there at that point. You see, in this case, guys, you're not given the x coordinate at that point. You are given what? The gradient. So you have to take the first derivative, equate the gradient, you're going to find what? The point of contact. So now what you have now, you can take this, or yeah, take this to your left. You left 15 into what? Into 12. That's going to give you what? 28, right? So this is 28. So let me just remove that, and then you have what? 3x squared, and then divide by 3, divide by 3. 28 divided by 3, what's that? Let me see. Is it 7 or what? Let's see, 28 divided by 3. Hey, it's 28 over 3. Eish, I forgot that 2 is an even number and 8 is an even number. But 3 is an odd number. So, sorry for that, guys. So this is x squared is what? It's just 28 all over 3. So what do? You simply take the square root both sides. So when you take the square root, let's bring our calculator back. So the square root of the answer, does this make sense? 3 point something. Let me see if I write this correct. This is 3 squared. Okay, this 3 cubed and then squared the minus 12. This is the gradient, into x and then minus that. You take this to the left. You left 15 into what? Into 12. When you sum this 5, 6, 7, 5, 6, 7, you see 7, not 8. I don't know where I got that from. Just that I'm tired, guys. I'll show you the time now. I think it's 4 a.m. in the morning. So guys, this is 17, 17 into 3x squared divided by that, divided by that. So can 3 goes into 17. Let me see, 17 divided by 3. This 17 over 3. So this is square root of the answer. This one gives us something. 15 plus that, 27. Evan, it's 27. What? Now I see. Please forgive me. It is 27, not 17. Where did I get this information from? I'm just tired, Shem. Sorry, guys. So this is 27. Let's see, 27 divided by 3. This is the 9. So this is 9 is equals to x squared. Yes, forgive me for that. Never happened. Just that I'm tired. I'll show you the time. So this and this relation lies. You'll have x, so square root of, remember when you take the square root, this plus or minus. You have plus and minus what? 3. So now let's say this is a tangent to the graph. Calculate the x coordinate of the points. You heard that? The points, not just the point. So it means that x can either be 3 or x can either be what? Negative 3. So they will mark you there. Let me show you the time. You see what time is it? It's 15 minutes to 5. 15 minutes to 5. So now they say let me see red. We used red. So let me just use this one, pink. So now, for which values of x will the given function be concave? I told you before that concavity depends on what? On the second derivative. And up depends on what? On greater than 0. So what do we have to do there? Where can I squeeze this information? So I'm just going to say this is my 5.3 here. Forgive me here, guys. Forgive me, guys. I'm just going to squeeze that thing there. So let's take the first derivative of this function. We'll have what? We'll have 3x squared. We're taking the derivative of this. We'll have minus 12. Take the second derivative. We'll have 6x, then to 0, then divide by 6. Not exactly to 0. Remember, I said they said concave up, So you say what? This is your second derivative. You say this has to greater than 0. When you divide both sides by 6, divide both sides by 6, x is simply what? X is x will be simply greater than 0. Let's see if it makes sense. I'll always explain, don't worry. Let's see if it makes sense. Which the function? Okay, even though we don't have the function, I will sketch it for you that since the value of a it is greater than 0, you'll have a function that starts by increasing, decrease, increase. So remember, we read the graph from left to what? To right. So guys, when you read the graph from left to right, where do you have concave up? Concave up happens here to y to positive infinity. So this is true that x has to be greater than 0 there. Yeah? And then to those positive infinity, your graph will still be what? Concave up. So this is true. And again, you can also say that x is an element not including 0, but from 0 to positive infinity. So now let's come back here and say we can say that x is greater than 0, or x is an element from 0 to positive infinity, and they've explained why. Okay, so let's see this one now. Guys, please don't forget to subscribe now. Don't forget to subscribe to my channel. Help me reach 100 subscribers. Now, please help me reach 100 subscribers, and I'll help you reach your goals. Now, after this video, I'm going to do optimization. Yeah? And that will be it for calculus. So help me reach 100 subscribers. So guys, now enough with the talking. Let's say this is from Eastern Cape. The diagram below shows the graph of f of x, which is equal to this and this and this and this and this. So these are the turning points. So now 6.1, determine the value of a, the value of b. In this case, they are not showing you, or they are not giving you the value of a. They are not saying, okay, they gave you here. You can be able to see that a is 5, b is that. Yeah? This is the examiner that made this question was like, if you got 6.1 wrong, then here is 6 point, 3 marks for 6.2 and 6.3. Yeah, that was his A. So now, enough with the talking. So now, guys, since this is a turning point and we don't know the point here, but we do know the point again here, this is going to be -3. Remember, I told you about the constant. This is the y-intercept, where your graph cuts the y-axis. But now let's see if we're gonna have enough information. We're not going to use this one, because if we replace everywhere there is x with 0, this is a, remember the y-axis is a lane, x is equal to 0. You place x is equal to 0 there, now you're no longer going to find b. We're going to stick to this point. It's the same question we did, I think question 2, question 3 there. So now you first take the first derivative, since you know this point there, the point 2, or x is equal to 2, is the turning point. Yeah? You say that the first derivative is equal to 0 at the turning point. And you also know that the first derivative at x is equal to 2. It is what? It is 0, guys. So now it means we have to take the derivative of this, and then in the place of x simultaneously replacing with 2 there. So this is going to be -6 and then x, but in the place of x I'm placing what? 2, and then this is squared. Using the power rule, this is going to be what? 2ax, but I'm placing what? 2. And this is equal to what? 0. The derivative of that will give you what? Remember, there is b. Don't forget about the b. So when you take the derivative of b, you'll just have b equals to 0. The derivative of that is it's just 0 there. So now you'll have what is this? You'll have let me just punch everything there. So you'll have 4 times 6. That's like 18 or 20 something, if I'm not mistaken. Yes, -24. You see, it is negative 24. So now you left 4a, guys, I'm just tired. You left 4a plus b there, which is equal to 0, but it won't stop us from answering this question. It's just that I don't want to use my mind. But this was just easy. So guys, let's see what we have here. Now we have formed what? An equation. And you can simply take this to your left if you like, if you want. But let's just keep it here. Let's say this is your equation 1. Okay, let me just say 4a plus b. It is simply what? Positive 24. This is your equation 1. To find equation 2 is to also realize that this d is also a point to your curve. So you're going to say f at 2 gave you what? Gave you 9. So now f at 2 is going to be what? We are simultaneously replacing 2 in the place of x. So this is 2 cubed plus a into 2 squared plus b into 2 minus 3. This gives us 9. This is 8 times this will give us negative 16. 18, is it? This is 8. 8 times 2, that's negative 16. Plus 4a plus 2b minus 3. And then it's equals to 9. So we know that here we'll have negative 19 plus 4a plus 2b is equals to 9. Take this to that, or simply keep this side. Take this to that. You'll sum. It means now you'll have what is this? You'll have 8. Is it 8? 9 plus 9, that's 18. You'll have 18, carry 1. You'll have 28. This is 28. This side. So this is 28. So you can call this your equation 2. So now, if you have to check, you have 28, you have 24. So it means we can say equation 2 minus equation 1. So we are going to have what? The 4a and the 4a will rationalize. 4a minus 4a will rationalize. 4a minus 4a will rationalize. And then 2b minus b will be left with b. And then 28 minus 24. From 8 subtract 4, you're left with what? With 4. The b is 4. You're done like that. So now sub b is equal to 4 into 1, into equation 1. So you left 4 into a plus 4, which is equal to 24. So this is 4 into what? Into 20. Is it 20? Yes. Take this to that. You have 20 there. Subtracting 4, you have 20. Divide by 4, divide by 4. The 4 and the 4 rationalize. So therefore, this is what? 20 goes into, 4 goes into 25 times. Because 5 times 4, I know is 20. So this is 5. The answer is simply 5. And that should be your A. So you simply say your A is what? Is 5. And your B, that B, not that one. The B is simply a 4. Simple as it is, guys. So now they gave us the equation. Now calculate the coordinate of E. We know that E is the turning point. What do we do, guys? We take the first derivative. So let me use another color there. So you simply take the first derivative of your original function. This one, you have negative 6x squared plus 10x plus 4. Since they're looking for turning they're talking about E, which is a turning point, you equate this to 0. You'll have negative 6x squared plus 10x and then plus 4. So you just check there. You just if we can divide everything by 2. So let's divide by negative 2 throughout. So you'll have negative 2, divide by negative 2, divide by negative 2. This rationalizes. So this gave us a positive, what is this? A 3x squared minus 5x minus 2. 0 is equals to 3x into x, and then 2 and then this minus, and then plus 1. Does it make sense? Yes. So now we'll have 3x being equals to -1 divided by 3. So therefore x is simply -1 all over 3. This is x1, and then your x2 is simply 2. So this makes sense that this is 2. So it means that e is simply have what? -1 all over 3. So therefore, they said calculate what? The coordinated e. So it means even the y. So evaluate your function at -1 all over 3. You know we don't like wasting time. So let me take out our calculator here and see what we have. So we're going to say what? We are going to say what do I need the fraction for? Oh yeah, I need the fraction. Remember, this is 2 into -1 all over 3, and then what? And then the cubed. And then what you have again, you have the +5, -1 into 3, and then 2 squared. And then you have a +4 into -1 all over 3. And then what you have again, I think you have a -3. So let's see, we must have a negative y value. And the -100 over 27, I think, is the same as -7 over negative 3.7. So the answer is -100 all over 27, which is approximately -3.7. So therefore, your e, it is what? It is -1 all over 3. The y value is what? Is -100 all over 27, or you can simply say -3.7 there. So now guys, please don't forget to subscribe guys. Nah? I help you, you help me. Nah? So guys, it's not about subscribers, nah? It's about you learning. So that when you get into the exam room, you have that confidence. But in order for this channel to continue making videos, continue with the content, guys, I need subscribers. Yeah? I need you to help me grow this channel, and I will help you grow. So please don't forget to subscribe. If you are hearing my voice, you're under my voice, and you know that you haven't subscribed, please kindly subscribe. You don't have to if you don't want. It's okay. Yeah? So now they say now we have to determine the value of x, for which the first derivative is less than 0. So they are saying, remember, when your first derivative is less than 0, it means what? The gradient is what? Is decreasing. Yeah? And also your fs what? Is decreasing. So where is f decreasing? F is decreasing from there to up to there, and also from there to up to there. Okay, let me first answer like this. I'll show you. This is x is an element from -infinity to -1 all over 3. And then do I use union or or? Okay, let me use and or. I think let me use union. Yeah, let's use union. Or now let's use and. Let's use and this one. And from what? From 2, because I think now this makes sense. To what? To positive infinity. So now I want to show you how you deal with these things. Né? Remember, this is our first derivative. If you let this thing, okay, now I think this is the part, the fascinating part. Né? So I have to show you guys this one. Let me teach you this one. And this one you also apply it when you're solving inequalities. When you are busy with solve for x. Né? So this one you always remember this method, guys. So remember, we have to take the derivative of what? Of our original function. Our original function is that. Let's take the derivative of that. It's going to be what? -6x and then squared. And then plus what? 10x. I'm using the power rule. And then plus 4. So now, if you were to check, this is what? the parabola or your quadratic function. So now you want the root of your quadratic what function. So how do you use this? You solve this. You let this be 0, y be 0. You have negative 6x squared plus 10x plus 4. Remember, we're dealing with the inequality sign. Don't forget. Actually, let me just remove this. In fact, let me just remove that thing. Remember, this is your first derivative. You have to use the notation that we're given there. So remember, using this notation. Remember, when you're busy with solve for x, you'll encounter these types of question when you're solving the inequalities. So what you do, when you divide both sides by -2 to get rid of, reduce the terms there. So remember, you divide everything by, when you divide both sides, you also do it on the left side. Right side. So this and this will give you a positive value, which is 3x squared. And then what about this one? This one will give you a negative 5x and negative 2. This is what? Now, when you divide by negative, the inequality sign changes from being less than to what? Greater than 0. So now, you agree that to solve for x, you simply say this is 3x, this is x, and then what? This is 2, this is 1, this is negative, this is positive. And then you do it what? How do you deal with this? You now say CV. This is not curriculum vector. This is the critical values. So the critical values are going to be what? You just write down the critical values. It's just x is equals to what? Negative 1 all over 3. Or x is what? Is just 2 there. These are what? Your critical values. So now, your function is this one. You're solving this function, not that function anymore. So you have to look at this function that you have, and the value of a is positive. So whenever you're dealing with the root of a quadratic function, since the value of a is greater than 0, you have what? A smiling graph. Let's put some eyes there. You see, in the face, you see that smiling graph. Let me not remove it. You see, when I put the eyes there and then the face, you see, it is smiling. So it means now we just locate our x-intercept. This is negative 1 all over 3 and the positive 2 there. Since the value of a is positive, it means we have a function that does like that. So from if it will cut it negative 1 a third and a positive a half. The question is, where is your function? This now, remember, the first derivative gave you what? A quadratic function. We don't worry about that side now. We read this function and say, where is our function greater than 0? Meaning above the x-axis. Remember, when the inequality sign shows you greater than, or you have an inequality sign that says greater than, your solution, guys, is always outside. Please make sure you understand that. When you have greater than, your solution is always what? Outside. When you have less than, your solution is inside, meaning from here to here. So since it is greater than there, you can see it is greater than. It means the solution is what? Is outside. We're looking at where our function is what? Greater than 0, meaning where is our function above the x-axis. Where is our function what? Where? Above the x-axis. So this start to happen at this negative a third to what? To infinity, negative infinity, to negative infinity there. So it means that we can conclude and say what now? We can say x is an element not including infinity, but from negative infinity to what? To this point, or this x value, which is what? A third, and then or union from 2 to what? To positive infinity. Let's go back if we see if we have the same thing there. Yes, you can say or and. It depends on what you understand, guys. They will never mark you wrong. You can say or, yeah, I think you just use or, guys. Because it says it happens here or it can happen here. So whichever one you prefer, but just take or. Remember, when you solve for x, you say x is equals to 2 or x is equals to that. You don't say x is equals to 2 and x is equals to that. You say or. Ne? X can be 2 or x can be what? Or. You're saying or. Remember, in maths, or is saying x can either be this or x can be either be that one, the value that. Understand? So now this will be your answer, guys. Ne? This will be what? Your answer. So is there another notation that we can, or interval that we can use to write this? Yeah, let me try. If we can say x is an element, let's see, from negative infinity to what? I don't think it's gonna work. From negative infinity to 2. No, it's not gonna work. I was thinking about this other interval, but I think it's not gonna work here, ne? I think just stick with this one, guys, ne? And you understand where it comes from. So please stick with this one. I don't wanna confuse anyone. Of course, I can come up with the second interval, but stick with this one. I think this one is better because you understand where it came about. Everyone, you understand where it came about. So please stick with this one. Trust me, do that. Fine. So now, guys, let's take a look at the next question. Don't forget to subscribe, guys, please. So now, 6.3.2, they say that where is our f concave down? Remember, concavity depends on what? On the second derivative. And down depends on what? On the second derivative being what? Less than 0. You understand? So remember, this was our first derivative. So now let's take the second derivative. It is format for 3 marks. Ne? So it means if it is for 3 marks, they are going to mark you for taking the first derivative. They are going to mark you for taking the second derivative. And then the 1 mark is what? For the final answer. So always don't jump into conclusion, guys. So take this by step by step. So 6.3.2, you're going to take what? The first derivative. The first derivative is what? It's just that part there. Negative 6x squared plus 10x plus 4. They're going to mark you here. They're going to mark you again for taking the second derivative, which is negative 12x plus 10. And then you do what? You say now this has to be what? Less than 0. Not equals to 0, but less than 0. So negative 12x plus 10 has to be less than 0. And I will show you using the graph again. So it means you can have this negative 12 less than what? Negative 10. Remember, when you divide by negative both sides, the inequality sign changes from being less than to what? Now greater than. So now this is going to become positive, but now the equality sign changes from being less than to what? Greater than. So you have 10 divided by by 12 then. So now let's see the factors. Let's use 2. 2 goes into 10 5 times. 2 to 12, it goes 6 times. That's 2, 4, 6, 8, 10, and then 12. That's 6 times. So this is 5 over 6. So x has to be what? Greater than 5 over 6. Let's go back to the function. Remember, the value of a is less than 0, meaning you have this function that does like that. Is it less than 0? Yes. You check this one. You see the value of a here. The value of a is what? Is less than 0. Meaning your function does like that and then down like that. So it means now going to what? To our right. Remember, we read the graph from left coming to what? To our right. So if you come to the right, approaching the right, you see you have what? Concave down. So this makes sense. You see that x has to be a positive value that is greater than what? This one here. The one that we have here. So this has to make sense, guys, please. Ne? Just to what? To make sense. So make sure you make sense of it. And this one here, where is f increasing? Where is the original graph decreasing? So let me show you. The original graph is decreasing from negative infinity up toward this point. So we said from negative infinity up to what? That point. And also it is decreasing forward from what? From 2 to positive what? Infinity. And again, I have shown you using what? The calculation, for those who didn't understand, so that you all understand. Yeah, so that you be able to have that confidence and get those full marks. So now, guys, this is the last question for question 6. They see now, let's check. Okay, they say that we have to determine the equation of a tangent to the graph of f at p in the form y equals to. Guys, if you have watched my videos from part 1 and then now part 2, you now understand what we are dealing with here. Whenever they talk about the tangent, what the first thing that must come or should come to our mind or rings is what? Is the first derivative. No? The first derivative is what? There is a relationship between the first derivative and the tangent at that point where the tangent happens. Understand? Where the tangent happens, there is what? There is a connection between the gradient of what? Of your tangent and the gradient of what? The graph. So they are exactly the same at what? That point. So now you are given the point. It means what you have to do is to say what? Is to take the first derivative of that function there. So remember, there is a mark for taking the first derivative. So which one? Let me just use this one. So remember, let's number this 6.3.3, this one. Eh? So I'm just going to say this is 6.3.3. So now, this is f, this is f. So if we can take the derivative of f and say f prime of x, this is our first derivative, right? Just write that. No? So they are going to mark you for this. Not jumping to conclusion, you say your answer is this. Yeah. So now, this is your first derivative. The first derivative I told you, and I will tell you again, that this expression that you have now, this is the gradient. Yeah? But you don't know exactly the gradient. What is the gradient exactly like? Using like just by this equation. Yeah? If you don't have the x values. So if you don't have the x values, it's like I can say this function is like a reaction. Whatever you put there, you're going to get what? The product. So it's like let's like it's like hey, there are people who are not doing chemistry here. Let me not get to that. Ne? So like think of this as like a reaction. Ne, guys? This is a reaction. And then when you add something to this reaction, you have to get what? Product. So think of this first derivative as a reaction. Whenever you add something to this reaction, it gives you something different every time. Ne? When you keep changing what? Changing your reactants. Ne? When you keep on changing your reactants, it keeps giving you what? Different gradient. So now at x is equal to -1, let's find the gradient there. So we know the gradient will keep on changing if we change what? The x value. Understand? If we change what? This x value, the reactant. So now let's put it inside the reaction there. So this is -1 squared plus 10 into -1. So now this is your reaction. Let's cook. Ne? Let's cook. So when we cook, let's see what we get there. This will be what? The product. Ne? Let's see what is the product. So now we want to cook. Let's see what is the product. So this is -1 squared. So we are inside the process. So during the process, this is what is happening. And then you add the salt, and then it gives what? -12. So this is what your product now. So this is what your product. And if you keep on changing this value of x, guys, the gradient will also what? Fluctuate. So when x fluctuate, your gradient also what? Fluctuate. Understand? Okay. So now this is the gradient. And this will also be what? The gradient of the tangent, because we know that the gradient of the tangent and the gradient of the graph at that point, the P, they will be the same. Yeah? They will be what? The same. So now we have to determine this equation in the form that y is equals to. But we also know the point, which is x, and also what? The y. So now your equation is what? Is y is equals to what? Mx, which is negative 12x plus c. To find c, just use that point there. So your y is what? By looking at what you have there, your y is 0, ne? Your x is what? Is negative 1. And then plus what? Plus c. This therefore give you c to be what? A positive 12. And this will therefore give you y, it is equals to what? Negative 12x plus 12. And this will be what? The answer, guys. For what? For 6.33 that I said there. So that was why we came out with. Yeah. So this is what I wrote here before. That this let's let this to be our 6.3.3, and this now this is the equation for 6.3.3. We came up with that thing there. So guys, please don't forget to subscribe. No? We are not done. Don't forget to subscribe. This one is a very fascinating one. Yeah? I want you to understand or pay more attention to this. Yeah? Please pay more attention to this. So now, don't write anything, just listen. You write after. Just listen. They say that the diagram below shows the graph of f. Of what? F of x, which is equals to a raised to an or a multiplied by x raised to an exponent of 3, the power or the order is 3 plus b x squared. The value of a is greater than 0, meaning your graph will start by what? Wait, this one starts by decreasing. It means now your value of a has to be what? Less than 0. Since we see the sketches like that. Understand? So now they say the x coordinate of L and M are 1 and 2. So L, guys, is given by what? The x is 1. And then M, read there, they say is 2. So if you read there, you see 2. So now they say the average gradient. So the gradient between the L and M is what? Is 5.5. So the gradient between these 2 points is what? Is 5.5 there. So now they say the equation of the tangent to the curve of f at x is equal to 6. Excuse? This is what? This is the tangent there. The equation of a tangent at x is equal to 6, meaning here maybe you have something like this, and then it is decreasing. Yeah, you have a negative slope. So now, guys, 7.1 for 5 marks. Yeah? Pay more attention. They say that we have to show that. Okay, let's forget about that now. You know it's not gonna help us for now. So this is 7.1. Ish. Let me just So this is question point 7.1. So now, guys, since you are told about the gradient between 2 points, you have to think about what? The formula to calculate the gradient of a straight line. It is what? The rise all over what? The run. The rise is what? Your y, changing y, y2 minus y1. Your run is what? Your x2 minus what? X1. Why do I say run? Run, you just run like that. Rise, you just what? Rise up like that. You see, you're going up. That's what y. When you are just moving to the left or moving to the side, that's what just run. So now we are going to make the substitution then. So if now, pay attention, guys. Don't write anything. Pay attention. So now, if x is 1, so what is y if x is equals to 1? So we're going to say, okay, what is y at f is equals to 1? So if x is equals to 2, the corresponding y value also this side will be what? f at what? At 2. Understand? It has to match, guys. This point there at the turning point has to match with this one that you have here. So if you have 3, you'll say, okay, f at 3. Understand? Okay. So I had to clarify that. So now you evaluate your function at x is equals to 1. You'll find y. Evaluate your function at x is equals to 2. You find what? Y there. So now let's make the substitution. This is going to be our y2, which is what? The f2 minus the f1. No? Over what? The x2, it is what? The 2. It has to match. Minus what? The 1 there. But we are given what? The gradient. The gradient is 5.5. The gradient, guys, between these 2 points. So it means you have what? F at 2 minus what? F at 1. Like that. And then this is over 1. You know it will be over 1. So I'm just going to leave that like that. So now, guys, take a look at what we have as the numerator there. We are evaluating our function at the original value of what? Of 2. Or we are evaluating our function at x is equals to 2. Our function is what? Is f of x. So now let's go and evaluate that. So I'm just going to say, okay, at f is equals to 2. You are replacing in the place of x, or everywhere there is x, with what? With 2. You'll have what? You'll have a into 2 and then cubed plus what? Plus b into 2 and then squared. Also evaluate at x is equals to 1. You'll have what? A into 1 and then cubed plus b into 1 and then squared. This is equals to this is equals to. This will give you 8a and then plus 4. Not 4, yes, I think 2 squared, that's 4, and then 4 multiplied by b is 4b. So this will be a plus b, guys. 1 cubed, the 1 raised to a million is just 1, guys. So this is what you have now. Remember, this is f at 2, f at 1. So let's make the substitution. So this is 5. This is the gradient, 5,5. So f at 2 is just that part. So this is 8a plus 4b minus what? A plus b. You protect. So when you distribute the negative inside there, you're going to have what? Negative a. When you distribute the negative inside there, you're going to have what? Negative b. So it means now you have 5.5. So this is 8. 8a minus a will give you what? 7a. 4b minus b will give you what? Positive what? 3b. You understand? And you can name this your equation 1. So now, this what you have here, it is going to give us what? Equation 2. Next, I'm going to show you how. So now let's read. There is a full stop there. They say that the equation of a tangent to the curve. Haha. I think by now you understand something that I already told you, that whenever you have a tangent to a curve, it means we have to differentiate this curve so that we can equate what? The gradient of the tangent and the gradient of what? Of the curve, because they're exactly the same at what point? X is equals to 6. You understand? So now we're going to take the first derivative of our original function. When you take the first derivative, I'm using the power rule. You have 3. Okay, let me use let me change color there. Let me change these things and use another color there. So let's use this one, so that you understand the steps, so you don't think it's one thing. So I'm saying take the derivative of your original function. Why are we taking the derivative of original function? Because we know there is a tangent at f. If we can get the gradient of this, we can be able to solve that. So now this is going to give you what? 3ax what squared plus 2bx. So this is the gradient, and this is also what? The gradient. So you equate them, the gradient of the tangent and what? The gradient of what? The curve. They're exactly the same. At what? At point x is equal to 6. So now substitute 6 in the place of what? Of x. So you have 3a into 6 and then squared plus 2 b into what? Into 6, like that. Now let us take out our calculator. It is 26 past. Have you seen the time? Have you checked the time? It's 26 past, guys. So this is 108. Okay. So we have negative 18 into 108a. 6 times 2, that's like 12b. So we can simply divide both sides by 12. 12 to reduce the terms there. So we have 12. So this and this rationalize, you have plus b. So let's see, 108 I think is like 7 or something. Let's see, divide by 12. 9, yeah, whatever. 9. This is 9a. So what about this? Let's try again. So I think it's going to give you a fraction, maybe 3.5 if I'm not mistaken. 18 divided by 12. 3 over 2. Yeah, you can say what are the factors of, or what factor can we use that can, or factor that can get to 18 and also to 12. Understand? So we can use 6. 6 goes to 18 how many times? 3. 3 times 6 will give you 18. So this is 3. 3 goes into, okay, 6 goes into 18 3 times. And then to 12, 6 goes into, how many times? It goes 2 times. No? So now you have something like this. Remember, they wrote this as what? As a decimal. So now let's turn that into a decimal sign. So just click to that button, you'll have 1.5. So this means I can erase this. Now we don't want to waste space and time. So it is 1.5, but don't forget about the negative 1.5 there. You want negative 1.5 because we saw that we have a decimal there. So guys, remember that we have to subtract equation 2 or equation 1 from equation 2. But if we can subtract them right now, things are not going to cancel because you have 3b, you have b, they are not going to cancel. So now in maths, we cheat like this. If this is 3b, let's make this 3b. How do we make it 3b? We simply multiply by what? By 3. When you multiply by 3 here, I think you'll have negative 3.5 there. So let me show you. Yeah, multiply this by 3, you'll have negative, or 4.5. Yes, you add the 3 there. 3 plus 1, that's 4.5. Ne? So you'll have negative 4.5, and then let's say 9 times 3, this is 27. So it means now here you have negative 4.5, and then you have what? 27a, and then plus 3b now. So we can turn this equation 2, so that when we subtract the two equations, the base and the base can rationalize, so that we can now solve what the a's, since we have the constant on our left hand side there. So now I'm just going to use red. So we're just going to say what? Let's see. We have 27. We have 7. So 27 is much bigger than 7. So you say equation 2 minus 1. So negative 4.5 minus this. Let's see what is that. So you say negative 4.5 minus 5.5. This is negative 10. Yes, negative 10. So you have negative 10 into 27 minus 7 is 20. Ne? So you have 20a, the 3b, and the 3b rationalize. You see now you can able to solve what for a. So this and this rationalize. So now I'll always teach you this. You need the factors that can get into 10 and also into 20. What are those terms? 10 goes into itself how many times? 1 times. To 20 it goes 2 times. A is simply negative a half, and this is true. So A is simply what? A negative a half. Don't forget to subscribe, guys. So this is your A. Let me just write it like that. So now you're going to say, let's see if you have a space there. So you're just going to say sub A is equals to negative half into what? Choose which one you want there. Let's see. Let's take 1. into 1. So it means now we have 5, 5 into what? Into 7, and then negative what? 1 all over 2, and then plus 3b. And then this will give you negative 7 over 2. You take it to that side, you'll have a positive 7 over 2. So now you'll say 5.5 positive plus, remember when you take it to your left, now it becomes 7 all over positive 7 over 2. We understand each other now? So it is 9. So it is what? It is 9, which is equals to 3 into b. So now you divide both sides by 3. I'm also going to show you how we deal with this thing. You see, what are the factors, or not the factors actually, because now 3 goes into 9. How many times? 3 times. That's 3, 69. If you have something like this, let's say you have 3 all over 9. You say what? 3 goes into itself how many times? 1 time. To 9 how many times? 3 times. But in this case, you have 9 divided by 3. So 3 or 9 can be divided 3 times. Ne? So it's just 3. So 3, 6, 9. That's 3. You can simply remove this as just for explanation. Guys, please help me reach 100 subscribers, please. Please, guys. So now that's what we have now. Okay, so now that's what we have. So now let me show you another thing. This is 7.2. They say that the equation of f of x, which is equal to that, it is given. Determine, you see, it is given now. Now they gave you. You see, the examiner don't want you to fail. It's like, I know there are students who will have gotten this wrong. Yeah? So now let me give them 3 marks now. Yeah? So now you are given or who have look at it and say, wow, I cannot do it. So now he's giving you the examiner. It's like, now you can start writing. You cannot skip the whole question. Now you can start writing. So now this is determine the coordinate of n, the turning point of. You see now you're being told that it is the turning point. You know, sometimes the examiner will not write this statement. You'll just say determine the coordinate of n. You know yourself. You're a student. Yeah? You know what is n. N is what is at the turning point. So it means they need the value at the turning point. So what you have to do when you hear about turning point, you do what? You take the first derivative. No? You do what? You take the first derivative. So it means now, let me first that before that, let's write down our function. This is negative a half into 3 plus what? Plus 3x into 2. You take the first derivative. After taking the first derivative, you use the power rule here, né? While taking the derivative. So this times that will give you negative 3 all over 2x into what? Into 2. This will give you what? Plus 6x. So now, you know the gradient at the turning point is what? Is 0. I should have stated here that when we take the first derivative, we equate to what? To 0 to solve the critical point at the to solve the critical points at the turning point there. You know, or just to solve the critical point, because the critical points are the x-intercept at the turning point. All that holds one way defines everything, or there, you know, or signifies everything there. So now you have something like this. You let this equals to 0. You have something like this plus 6x. You see this one is negative. Take the one with a negative sign to your left. Now it becomes what? A positive sign. Or you can just say, remember guys, you don't just take things to your left, to your right. Just observe before you can do anything. You have x. It means x is common everywhere. That's your fact. So if you have x and x, you don't take the x to and take it to that other side, and then still you have x to your left. It doesn't work like that. So it means since x is a factor there, you say x into what? Into negative 3 over 2 what? X. When you multiply this and this, you get to the same thing. And then you have what? Now you have the 6. So now you can solve for x. So x1 is simply what? Is simply 0. Your x2 will be what? It will be, let me show you. You say negative 3 all over 2 is equals to what? Remember you have x is equals to negative 6. X is the same as multiplying by 6 multiplied by 2. You have the negative, don't forget the negative, and then over 3. 6 times 2, that's like negative 12 divided by 3. And then 12 goes into 12, or 3 goes into 12. How many times? 4 times. That 3, 6. It's 5 times. Then 3, 6, 9, 10, and then 12. Is it 12, guys? 3, 6, 9, 12. It's 4 times. It's 4 times. So the answer here is simply 4. If you don't trust me, let's see using your calculator. Again, you always want to use your calculator. There is a good thing, eh? So negative 6 divided by what? By 3 over 2. Now don't worry about the negative. Just want the value now. You see? So it is a positive 4. Don't forget about the negative sign there when you divide both sides. Yes. So now, let's say determine the coordinate of n. You go back to your diagram. Can n be 0? The answer is no. It means that at O, that the origin, it is 0 and what? And 0. So n is somehow 4 there. Yeah? So it means since it is 4, they are looking for a coordinate, not just 4. So you evaluate your function at 4. At x is equal to 4. At the original value of what? Of this. So everywhere there is x, simply place that 4. Now let's do it together. So now we're going to see what this is negative 1 all over 2 into what? Into 4, and then you have the 3, and then plus 3 into 4, and then what? Squared. So this is 16. Does it make sense? Yeah, we'll go back to the diagram and offset. But it makes sense, I know. Since A is at the maximum, and the corresponding y value has to be positive there. Yeah? So it means now this is n is simply 4 and then 16. Let me show you. If you have to check, remember, hey, okay, let me just make sure that this is aligned to the graph there. Remember, you evaluate your function at what? At 4. You give us what? 16. So this is 16 there. And then, like that, we are done. And this is n. So I can come back and say n. It is simply 4. Simply 4. 16. So now let me erase this part. Let me just erase this part there. Then like that, so that I can be I can have space for the next question. Eh? So now let me see if I use this one. So let me just divide that. So this is 7.3. So now guys, listen to the question. They say that the graph of f is concave up for xk, x less than k. Let's see if that makes sense. Is concave up for less than k? Yes, it makes sense. Going to the, remember, less than meaning going to the negative side. Ne? Your function is what? If you have to check there, your function is concave up. Ne? It's concave up. Remember, when you read the graph from, you always read the graph, guys, from left to what? To right. So when you read from left to right, this is concave up until to point of inflection. But they're saying it is concave up for some x values less than k, meaning going to the left. You see, that's when you'll see it like nicely that it is concave up, it is caving up. But when you come, you are just coming from this side, you say it is going down like that, but still it is caving up. Yeah? Okay. So, but Remember, as I said, the concavity depends on what? Depends on the second derivative. And up depends on what? Depends on greater than 0. Always remember that. So now, this was our first derivative. So we write that down so that we can get that mark. So this is negative 3 all over 2x squared plus 6x. We take another derivative, second derivative. So now this is going to be 2 times 3, that's negative 6, divided by 2, that's negative 3x plus 6. Take this, remember now this is your second derivative. So you say negative 3x plus 6 is what? Is greater than 0. That's concave up. So now you can say negative 3x greater than what? Negative 6. You take this to what? To the right. When you divide both sides by negative 3, guys, what happened to the inequality sign? This inequality sign changes from being greater than to what? Less than. This is why they said for some x values less than. Yeah? So now let's see, 6 divided by 3, that's 2. So let's go back to the function. It means concavity happens here. This is the point of inflection where the graph is either concave down, concave up or concave down. So x is simply less than 2 there. So guys, please don't forget to subscribe now. And before that, we are done with these questions. Next time we'll do optimization now. In our next video, we'll do optimizations. So guys, you know the thing, you know the rule, or you know what to do. It's not the rule, but you know what to do. You have to support, né? So please don't forget to subscribe to my channel. So you support by subscribing, né? So I just want to show you something here. If there is a person who don't know how to like deal with this, né? Please leave a comment, or just leave a comment there in the comment section. Né? Leave a comment if you'll be struggling here. So this is 7.1. You take from the first derivative, this is 7.2. So guys, picture this. So if you're still having challenge with these things, leave a comment there. I will help you. I'll make a video just on this, just on this part, just this question 7. If you have a challenge on this and think, man, I don't know, 7.3.1, or maybe explain. You see, I don't know 7.3.2. I will explain. Ebon, I'll explain. So please, guys, don't forget to subscribe to my channel. And thank you for watching. And I'll see you guys in our next lesson. In our next session, we'll be busy with optimization. We'll be busy optimizing rectangles, optimizing cycles, squares, and so on and so forth. Né? So guys, don't forget to subscribe and always stay active, study smart, and don't forget to study hard. Né? And always don't depend on yourself only. Always believe that there is God in heaven. There is also God in you, in your environment. So always pray, read scriptures every day, ask God to help you. There is this verse, I think it's Proverbs 16, verse 3. It says, do not lean on your own understanding. In everything, submit to Him, and He will make your path straight. So, meaning, do not depend on your own understanding, your knowledge about physics or math. You have to pray for God to help you. Everyone, you have to pray for your exams. Pray. Everyone, set goals. Know what you want to aim. Write down your goal. Look at it each and every day while you start. That's the first step. Trust me. So thank you guys, and I'll see you guys next time. So let's see, what time is it? What the hell? 40 minus 2. 6. But that's okay. Thank you guys. See you guys next time. Don't forget to subscribe. Ne? Help me reach 1. Even 1K. Even 2K. Even 100K.